Yes, I'm serious. Today we'll be doing 100 algebra problems, and of course we'll be doing them in one take. The file will be in the description for your convenience. We will be going over 10 categories, and these problems are mainly for calculus. So let me tell you guys that in calculus, it's not the calculus that gets you, it's the algebra and also the trig that gets you. And let me tell you, this right here, I don't think it's enough, but it's a good start because I didn't include like quadratic equations and all that stuff, but I will have a separate video 100 algebra equations, solving system equations, quadratic equations, completing a square, etc. over there. And also, we need a trig as well, but that will be for later on. Today, just focus on the algebra. So let's just go ahead and get started. So the first category, I called it factor and cancel. The first question is x squared minus 6x minus 7 over 2x minus 14. So the deal is that we just factor the top and factor the bottom and then cancel things out. On the top is a trinomial. Well, this right here is not bad to factor because we just need x times x. And then to get negative 7, well, what times 12 give you negative 7? Together they add up to be negative 6, right? We need negative 7 and positive 1. Okay? And then on the bottom right here, we can just factor out a 2. And then we see that we get this, and then this and that will cancel. So we get x plus 1 over 2, and then we are done. Yep, the first question, nice and easy, huh? Oh, by the way, this right here, sometimes if we cannot factor, maybe we'll have to do long division. And again, this is just like a overall review, like a ultimate study guide, algebra review when you are taking calculus or before you are taking calculus, all that stuff. So hopefully you guys will find all these things helpful. Either you are about to take calculus or you're in calculus and then just one more review. Anyway, number 2, we have x squared plus x minus 6 over 4x squared minus 5x minus 6. Alright, on the top, this is not back to factor, and let me tell you guys this little thing. Sometimes when we want to factor things out, let's just put the result above it. It's easier that way. So if we do that, well, we get x and x. 1 times 12 gives us negative 6. Together they have to be positive 1. Well, the combination will be plus 3 and minus 2. And now to factor the bottom, this is not so nice because we have a 4 in front of the x squared, but don't worry, I will show you guys with the tic-tac-toe method on the side. 4x squared minus 5x minus 6, tic-tac-toe in action. 1 times 12 gives us 4x squared. Yes, we can use 2x and 2x, but let me tell you, let's try 4x and x, alright? Why? This is going to work, let me show you. We are going to break down negative 6. 1 times 12 gives us negative 6. Well, negative 2, positive 3, or negative 6, 1, or maybe more, right? The correct combination is that we are going to put, let's say, negative 2 here and 3 right here. Let's see if it works. Well, it does work because this times this is negative 8x, and this times that is 3x. Together, we do end up with the negative 5x. So that means this right here can be factored as read it across, okay? So 4x plus 3, and then x minus 2. And you see it, this and that cancel off very nicely, of course. And we will just get x plus 3 over 4x plus 3. And of course, do not cancel the 3, just leave it like this, right? So that will be for the first 2. Alright, so let's go on algebra problems. Okay. So again, all these are just pretty much algebra drills that you should know. So that's why we can go a little bit faster than usual. But again, if you need any help with any specific topic, feel free to comment down below and let me know. Let's see, number 3. I have 49 minus x squared over, on the bottom I have x squared minus 9x plus 14. Alright, on the top, we have 49 minus x squared. I like to call this out of order because we usually like to have the x squared part goes first. Right, especially on the bottom we have the x squared part goes first already. So I'm going to just switch the order of the subtraction and make sure that we take out a negative, like so. And then for the inside, we can put this down as x squared minus 49. This is true because if you distribute it, you see this times that is negative x squared, and this times that is positive 49. So let's take this part, and then right here, let's just write it down again. Okay, now let's factor it. On the top, we still have the negative. This is x squared minus 7 squared, so we can use the difference of two squares formula. Factor this as x minus 7 times x plus 7. And on the bottom, well, let's see, x and x, okay, to get 14, and together we need to add up to negative 9. Let's use negative 2 and negative 7. Yes, this and that cancel, and we have the following. Notice that the answer is negative. It depends how you want to write it. You can put a negative at the front like this. If that's the case, on the top you can just leave it as x plus 7 over x minus 2. You don't need the parentheses if you put a negative at the front right here in the middle of the fraction. So this technically this is invisible parentheses, you have to know. Likewise, the bottom there's also invisible parentheses. If you want to write the negative on the top, then make sure you write it like negative parentheses x plus 7 over x minus 2. Of course, if you want to distribute, be my guest as well, but I'm going to leave it like this, right? So that's number 3. Okay, number 4. We have 25 minus 4x squared, and then over, all right, 2x to the third power minus 3x squared minus 20x. All right, on the top, again, this is out of order. We like to have the x squared term goes first. So let me just switch the order of subtraction. I will put down negative parentheses, and then the inside, this is 4x squared, and then minus 25, similar to this one. And then on the bottom, let me just keep it as how it is. And then I'm going to factor the top and on the bottom as well. All right, so on the top, it's a difference of 2 squares. So let's write down the negative. This is 2x squared minus 5 squared. So we get 2x minus 5 times 2x plus 5. On the bottom, let's factor on x first. So we get x, and then here we have 2x squared minus 3x minus 20. Okay, this right here is a trinomial. Again, the coefficient right here is a 2. So maybe we will need to do some scratch work on the side. Let's see. Tic-tac-toe in action. 2x squared minus 3x minus 20. And of course, if you can just look at it and then write down the correct answer, be my guest as well. But anyway, already let's see 2x and x, that's the only choice. And then to get negative 20, let's see, shall we do 5 and 4? 4 times 2 will be 8, and then 5, well, they are kind of 3 away, right? So I'm going to put down 4 here and then 5 here. And I need to get a negative. I need this to be negative 3, so this should be bigger, right? Because together we get a negative 8x. And then this right here is 5x. Together we do end up with a negative 3x. All right, so here we have x times, radial across, we have 2x plus 5 times x minus 4. Good. And then let's see, what can we cancel? This and that. So let's just put the negative at the front right here, and then like that. And then 2x minus 5 over x right here times x minus 4. Usually, you want to keep the top like distributed or factored, or just leave it like that. On the bottom, leave it factored like this. All right, so that's usually the case. So do you guys miss the algebra days? All this stuff? Yeah. And in calculus, you know, all these algebra things is just going to be like a little thing, the little steps of your big calculus questions, right? And later on, I'll also tell you guys the simplifications that you guys will have to do, because you guys will encounter that when you do the derivatives. So I'll tell you guys once we get there. And let's see, number 5. We have the following. On the top, we have a 4-term polynomial, x to the third power plus 3x squared plus 4x plus 12 over 4x plus 12. So on the top, we have 4 terms. Let's go ahead and use factor by grouping. That's usually a strategy for that. And in fact, if you want to do this right here by long division, yeah, maybe, but you'll end up with like fraction. So up to you. Let's go ahead and factor by grouping, because we noticed that these 2 terms we can factor it with the x squared on the outside, and then we get x plus 3. And then these two terms, notice this and that are the same, but do not cancel this and that. We must factor the top and then cancel things out after that. So this and that, let's put on the plus right here first. And 4 and 12, we can factor out 4, and then we have x plus 3 left, like this. On the bottom, we can factor out 4, might as well, right? So let's put down 4 and then x plus 3. And notice everybody has the x plus 3, but let me do this properly. Let me factor out the x plus 3 right here, and then we have the x squared plus 4, and then over this and that, which is 4x plus 3. And we see this and that cancel, and we get x squared plus 4 over 4, and then we are done. So just like that. Yeah, and notice that yes, you can just like cancel this out, but like usually I prefer to show my students factor everything completely on the top and then cancel out the factors. Yeah, and pay attention to the top right here. Notice that everything is multiplying, or two things are multiplying. That's how we can cancel this and that. Later on, we'll encounter some trickier questions, right? So these are just for like warm up, the good old algebra days. The days that you didn't really need to study and can still get the A on the test, right? Yeah. Anyway, number 6. Right, kind of reverse it a little bit. We have 2x minus 6 on the top over, on the bottom we have x to the third power plus 5x squared minus 9x and then minus 45. All right, so let's see. On the top, I'm just going to factor out 2. X minus 6 like this. On the bottom, again, factor by grouping. Right here, I'm going to take out x squared, and then we get x plus 5. All right, now right here we have the minus. So let's go ahead and write that down right away, just like what we did earlier. It was a plus. We write it down right away, right? Okay, and then let's look at the 9 and also the 45. We can factor out 9. So let's put that down right here. But you see, this way right here, we are technically factoring out a negative 9. So be really careful. Originally, this term is negative 9x, but we took out the negative 9. So right here, we just have x. And then this is negative 45, but we took out negative 9. So just do this. Negative 45 divided by negative 9, we get positive 5. Yes, this and that will have to be the same, right? Yeah. Ooh, hold on one sec. My bad, sorry. X minus 3. Just kidding. Okay, now let's see. Right here, okay, let's do this. Because I know on the bottom we can keep factoring, right? So let's just go ahead and put this and add like this, x plus 5, and then times x squared minus 9, like that. Good. But the thing is that, notice, x squared minus 9 is actually factorable because this is the difference of two squares. Earlier, we stopped it right there because that was not factorable. Alright, so let's go ahead and just factor this, x plus 5. Factor this, we get x minus 3 times x plus 3. Yep, x minus 3 and x minus 3 can be cancelled. And finally, we have 2 on the top over x plus 5 times x plus 3. And then we are done. Okay. So for this one, you might have been wondering, don't we want to just split the fraction and write it down like this, x to the second power over 4 plus 4 over 4, and then you can also write this as x squared over 4 plus 1. You could, but this is also okay. So depends how you like it. Sometimes you actually have to write it down this way, it's actually easier, but we'll talk about those situations later. And then as you can see right here, I just leave the answer in the factorative form, especially for the denominator, and on the top we actually just have 2, so that's what we have. So far so good. Yeah, so for a lot of this, seriously, just go ahead and do the work and know the usual things that we have to do, that's all. So remember your algebra. And seriously, we'll do like 100 algebra equations that you guys should know, like quadratic equations especially. Alright, number 7. x to the third power plus 125 over x plus 5. So I'm going to show you guys two ways to do this. The first way is by factoring. So here we have x to the third power plus 125. This is the sum of two cubes. It's actually factorable. Earlier, the sum of two squares is not factorable. This right here, when we have a to the third power plus b to the third power, to factor this, we get a plus b times a squared minus ab, and then plus b squared. So this is the sum of two cubes factoring formula. And the way I like to remember it is plus plus minus. The last one is always plus. Why do I say always? Because if we have a to the third power minus b to the third power, I might as well also put this down for you guys, because later on you might use it. If we have this, then we get a minus b times a squared plus ab, and then plus b squared. You see the last term right here is always plus. And for the minus version is minus minus plus. Cool, so that's what we have. And of course, we are going to use the first one for this. So notice, x to the third power plus 125, we can write that as x to the third power plus 5 to the third power, and over x plus 5. When we factor this, well, x is the a, 5 is the b. So we get x plus 5 times a squared, which is x squared. Let's go and write that down. And then next we have the minus. And then ab means this times that, which we have 5x. And then lastly, we have the plus b squared. 5 squared is 25. So right here, let's put on 25. And then all over the denominator, which is just very nice, is just x plus 5. Better yet, this x plus 5, that x plus 5 cancel, and finally this is the answer, x squared minus 5x plus 25. So that will be it. And of course, definitely remember these two factoring formulas for the sum and also the difference of two cubes. So this is the first way. Now the second way is that notice that on the bottom we have a binomial, and this is very good because we just have a 1 in front of the x. And this is super good because it's just in the form of x plus a number. So we can use long division or synthetic division. So I'm actually going to show you guys both. Alright, so let's see, x to the third power plus 125 over x plus 5. Synthetic division later. Let's do the long division first. Alright, so that's how you do it. This is how you do it. We are going to put x to the third power plus 125 inside, but notice we do not have the x squared term and we do not have the x term. So let's go ahead and add 0x squared and also 0x. They are just like the place value. It's just like if you want to write a check for $1,008, what do? 1 at the thousandth place and 8 at the unit place, right? But what's in the middle? You cannot just put 1,8, that's $18. You will have to put 0, 0, right? So it's like that idea. And then right here we have that 125 at the end. Okay, and then on the outside here we have x plus 5, and here we go. We ask ourselves, what times x will give us x to the third power? Well, the answer for that is x squared, so let's line up with the x squared right here. And we take the x squared times this, which is x to the third power. And then we take this times that, which is 5x squared. Alright, and then when we do long divisions, we are going to subtract, like so. And now, x to the third power minus x to the third power cancel. 0 minus 5x squared, right? And they are the x squared terms, so we get negative 5x squared. And then we bring down the 0x. And now we ask ourselves, what times x will give us negative 5x squared? Well, we need negative 5x. So let's put on my negative 5x right here. This times that gives us negative 5x squared. This times that gives us minus 25x. again subtract, and we see this and that cancel, 0 minus minus become plus, 25x, and bring down this 125. Finally, what times x will give us 25x? The answer is 25. So we add 25. So 25 times x is 25x, and then 25 times 5 is 125. And you can see that when you subtract, the remainder is 0. This right here is the answer. So this is also another way to prove that why the formula has to be like this. So the answer, of course, x squared minus 5x plus 25. Done. Long division. Now let's take a look at synthetic division. I'll do this one in blue. When we have x to the third power plus 125 over x plus 5. This is how we do it. Depends on how you have seen it before, but usually I draw like a left corner like this, and then you write down the coefficients of the numerator. So we have 1, and then again we have 0x squared, and then we have 0x, and then lastly we have 125. Now on the bottom we have x plus 5. In order for us to use synthetic division this way, make sure that we have a 1, and this has to be x to the first power, which they are, so that's good. And if this is plus 5, we are going to put down minus 5 here, the opposite. And this is how it works. First, we bring down the 1, and then we take negative 5 times 1, which is negative 5, and then we put it here. And then for synthetic division, we are going to add. So, and you might be wondering why. The reason is kind of like because we did the opposite, so that's why you add. Okay, so that's one of the reasons. Yeah. Okay. Anyway, this is just how people do it. Anyway, 0 plus negative 5, we get negative 5, and then just go and do it. Negative 5 times negative 5, we get 25, and then 0 plus 25 is 25. And lastly, this times this is negative 125. Together, we get 0. This is the remainder. It's 0. That means this goes into that evenly. And this is how we are going to read the answer. These are the coefficients of the result, the quotient. And earlier we started with x to the third power. That means this right here, we go down by 1 power. So that will be x squared, x to the first, and then no x. So this right here will give us 1x squared, which is just x squared, and then minus 5x, and then lastly plus the constant 25. Right? So 3 ways to do this question. So let me know which way you guys like the most. Later on, whenever we can factor, we factor, I will say. And then for the long division with synthetic division, I just practice. Maybe you'll use it here and there, and things like that. You guys want to take a guess right now if it's 1:15 a.m. or 1:15 p.m. 14 actually, 1:13, I don't know. All right, number 8. We are looking at x to the third power minus 27 over 3x squared minus 27. All right, let's go ahead and get started. On the top right here, it's a difference of 2 cubes. So let's recall the formula. This is x to the third power minus 3 to the third power. So we are going to get x minus 3 and then multiply by x squared plus ab, right? Just this times that, which is 3x. And then lastly, we add this square, which is 9. So this right here is the factoring for that. On the bottom, this is not difference of 2 squared yet, because notice, we have 3 here and also 27 here. We can actually factor out a 3 first. And then we get x squared minus 9. So let's put down this 3, and then x squared minus 9, well, that's going to be x minus 3 times x plus 3. So that's the factoring. And then we see this and that can cancel. That's it. So finally, we just write down the answer. We have x squared plus 3x plus 9 over 3 times x plus 3, and then we are done. Yeah, don't you guys just love algebra? Yeah. Okay, number 9. And by the way, a lot of these questions are actually based on calculus question. I just took away all the calculus languages and then focus on algebra. Alright, so later when you study like limits, you will see things like this that you have to factor and cancel. Yeah. Number 9, let's look at x to the third power minus 5x plus 2 over x minus 2. Unfortunately, the top right here is not easily factorable. It's not easy to factor. It's factorable, of course, but it's not easy to do that. So what do? Well, notice that on the bottom we just have 1x to the first power minus 2. So we can use the synthetic division. So let's go ahead and do that. Write down the coefficients. We have 1, 0x squared, so we put down 0, and then this is negative 5, and then we have 2. And then this is x minus 2. Look at the negative 2. We do the opposite, which is positive 2. Now, synthetic division action. Put down the 1, and then we do this times that, which is 2. And then we add 0 plus 2 is 2, and then we do it again. 2 times 2 is 4. This times that, this plus that is negative 1. And then this times that is negative 2. Put it here. Together we get 0. Ladies and gentlemen, this right here is x squared, because earlier it was x to the third power. So x squared plus x plus 2x, and then minus 1. Take a look right here. Can we factor it? No. This is a minus 1. If it was a plus 1, then yes, you can factor it. But right here, no. This is it. Okay, leave it like that. Cool. All right, number 10. I'm going to fit in number 10 right here as well. Here we have 2x to this third power minus 3x squared plus 6x minus 5. And then over x minus 1. So similar thing, just use the synthetic division. Here we go. We have 2, negative 3, 6, and negative 5. This is x minus 1, so we do positive 1 on the outside here. Okay, put down the 2. This times this is 2, put it here. This plus that is negative 1. Okay, this times this is positive, is negative 1. This and that together is positive 5. Yes, and then this times this is positive 5. Together we get remainder 0. So this right here, starting with x cubed, that means this right here is x squared term, right? So 2x squared minus x plus 5. Can we factor this? No, because I boxed the answer already. No, just kidding, of course. But like, it's really not factorable. That's why I just boxed this. Okay, cool. So definitely know how to factor and do long division or synthetic divisions. And of course, if you guys need more help with factoring, you guys can check out my other videos or just leave a comment down below and let me know if there's any specific type of algebra problems that you guys would like to see. All right. I know. How about the trick? I told you guys I will also work out the 100 trick. I don't know if I can actually come up with a 100 trick problems though. So it may take me a long while. I will try my best to actually come up with them as soon as possible for you guys. Okay. So let me just take a look. Good. Okay, number 11. Okay, from number 11 to number 20, we are going to talk about expand and cancel. So instead of factoring, we will actually focus on multiply things out. And then I'll tell you guys what the things that we should keep in mind. First one, x plus 2 squared minus 4 over x plus 2 to the third power minus 8. Alright, so again, expand and cancel. Here is a common mistake. A lot of students, when they see the x plus 2 in the parentheses right here on the top, and then on the bottom we also have the x plus 2 in the parentheses, right? They'll just cancel this and that. That's not correct. Alright? So let me show you what I mean. If you just cancel this and that, this is wrong. This is wrong. This is yeah, just don't do that. No. Okay, so for number 11, this is expand and cancel. All right, now number 11, x plus 2 square minus 4 over x plus 2 to the third power minus 8. Do not cancel this and that. The reason is because at the end here we still have the minus 4 and also the minus 8. If the question was this, x minus 2 square over x plus, sorry, if the question was x minus 2 square over x plus 2 to the third power, you see there's nothing else, nothing else. In this case, yes, we can cancel and say it's 1 over x plus 2. This is okay. But because of this and that, we actually have to multiply things out and then combine terms and then see if there's anything we can factor and then cancel. Notice this right here is actually the difference of 2 squares, and the bottom here is actually the difference of 2 cubes. But I find it's more straightforward if you just multiply things out and then combine and all that. So even though you can actually factor them and then cancel, but let's just multiply things out and combine terms and then factor. Anyway, right here, we have x squared, we have x plus 2 squared. First formula that you should know, definitely, okay? Whenever we have a binomial square, namely a plus b, if we have this square, this right here, we get a squared plus 2ab plus b squared. Alright, so we are just going to be using this kind of formulas in our head to multiply things out. Just make sure that you have that middle term. And also let me write down the minus version. If we have a minus b to the third power, to the second power, this right here is equal to a squared minus 2ab and then plus b squared. So this is how we multiply out these two things. So with that being said, let's just work that out the first part here. So notice x plus 2 squared. So we first square the x, so we have x squared, and then we add 2 times this and that, which is going to be 4x. And lastly, we have the 2 squared, which is 4. And then right here, we still have the minus 4. So that's the top. On the bottom, we have the third power. I will also give you guys a third power version. The third power version says if we have a plus b to the third power, the coefficients are 1, 3, 3, 1, because that's from the Pascal's triangle. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, etc. How did we get these numbers? Well, if you look at the 3, it's because 1 plus 2 is equal to 3. How did we get the 6? It's because you look up to the previous row and you just do this plus that and you get 6. How did we get the 4? 3 plus 1 is equal to 4, etc, etc. So when we have a plus b to a third power, we look at this row. This is technically the 0th row. So this is the third row. The third row, 0, 1, 2, 3. Because this is actually corresponding to the third power. So right here, how we can do it is just remember 1 times a to the third power. And then we add 3. And then right here we have a. The power goes down by 1. But introduce the b. Because the powers together, they have to add up to 3. Next, 3. And then a, the power goes down by 1, but introduce another b, so b squared, and lastly b to the third power with a coefficient 1, like that. Okay, and then if we have the minus version, let's say a minus b to the third power, this right here, it's pretty much the same thing, but then the sign in between alternates. We start with the positive version first, a to the third power, and then minus 3a squared times b, and then plus 3ab squared, and lastly minus b to the third power. So if you use this right here, yeah, it will also work out pretty well. Usually for the third power, maybe I would recommend you guys to actually write it down and just multiply things out, because if you do this in your head, it might be easy for you to make a mistake. So it takes practice, I would say. So let's see though. This is just foiling that out, right? Right here, x plus 2 to the third power. We start with x and we raise that to the third power. So we have x to the third power. Next, we do plus 3 times x squared. So we have the x squared. But we do 3 times 2 to the first power, which is going to be 6, right? Because we are following this formula. Next, we have plus 3. And then we have x to the first power. So let's put on x. But then we have to multiply by 2 squared. 2 squared is 4. 3 times 4 is 12. Okay? And then lastly, 2 to the third power is 8. So the blue part corresponds to that. And then at the end here, we have that minus 8. So that's how you multiply out the third power. I would maybe recommend you guys to really just practice this a few times, because it would be much faster. Yeah, because if you can save your time for doing the algebra here, then you can actually focus on actually learning the calculus, or like think about the calculus part. Yeah, I would say algebra should be your second nature when you are in your calculus class, because that's like the reality. You have to. Okay, here, let's do the Q things first. This and that cancel. This and that cancel. Cute, huh? Okay, anyway. On the top here, we can actually factor things out. Let's factor on x. And then we get what? X plus 4. That's it. On the bottom, can we factor anything out? X. Yes, we can factor on x. And then we get x squared plus 6x plus 12. Can we factor this though? Well, we can try, let's say x and x. To get 12, well, we can try 3 and 4, but together they add up to 7. We are trying to get 6, so this is no. Let's try 2 and 6, but together they add up to 8, not 6. So in fact, this right here is actually not factorable. We'll just leave it like this. And then this is x times that, and this is x times that. So this x and that x can be cancelled. Finally, the answer is just x plus 4 over x squared plus 6x plus 12. And of course, do not reduce the 4 and the total 12. Just leave them as how they are, because you see that x plus 4 is one term, one factor. Yeah. So that's that. Okay. All right, let me just erase this. Number 12. Here we have x plus 5 squared minus 9 over parentheses x plus 10 squared minus 4. Alright, so these are not so bad. Of course, you can again try to factor the difference of two squares, but I think it's just more natural to just multiply things out and then factor it. Yeah, so when we multiply out x plus 5 squared, we get x squared plus 2 times this and that, which is 10x. And then we add a 5 squared, which is 25. After that, we have the minus 9. Over, right here, multiply this out, we get x squared plus 2 times this and that, which is 20x. And then we do 10 squared, which is 100, and then minus 4. Okay, cool. Now, this and that can be combined. So we have x squared plus 10x and then 25 minus 9 is plus 16. Over, this right here is x squared plus 20x. This and that together is plus 96. Can we factor this? Yes. On the top here, we can break it apart as x plus 2 times x plus 8. On the bottom here, what times what give us 96 and together they add up to be 20. 8 and 12. It works. So here, so let's put on x plus 8 times x plus 12. Aha! We see that the x plus 8 in common, so cancel them out. And finally, the answer is x plus 2 over x plus 12. Yeah. Okay, I would like to take some time to show you guys what if we really did factor by the difference of two squares at the beginning. Let me show you. Firstly, we will look at this right here as our A, and then the 3 right here as our B. So I'm just going to erase the 9, and I'm just going to write it as 3 squared. And likewise, the 4, I will look at that as 2 squared. Okay, so A minus B times A plus B. We will have, the first part is x plus 5, and then minus 3 times x plus 5, and then plus 3. Over, right here, do the same thing. The inside here is x plus 10, so that's our A. So I'm just going to write here as x plus 10, and then minus 2 times x plus 10, and then plus 2. You see, if you use the difference of two squares formula to factor the top and bottom, it may take you some practice to get used to this kind of things, right? But the difference of two squares is not so bad, and it's actually much quicker because now we see this is just x plus 2, and then this and that is x plus 8, and 10 minus 2 is 8, so this right here is x plus 8, and then this right here is x plus 12. Aha! This and that cancel, x plus 2 over x plus 12. Yeah. Earlier, it was a difference of 2 cubes for number 11. That's why multiply out, I think, might be easier to follow along, but difference of 2 squares, you may also want to try this. Okay, so far so good. Yeah? So let me know, what classes are you guys taking? Maybe you're just taking algebra right now, but you just want to look at how the algebra will be in calculus and things like that. And again, all these questions, they're just like part of the calculus questions. Oh, by the way, do you guys recognize what this is? If you guys know, let me know. Number 13, one of my favorite ones. Number 13, we have 3x minus 2 times the parentheses, and then we have x plus 2 over, on the bottom we have 3 times x minus 4 times x plus 2. Hey, x plus 2 in the parentheses here and here, can we cancel them? No. If we cancel them, that's wrong. And the reason is because on the top right here, we have not cleaned things up yet. Because we have the 3x that's waiting to be combined with this. So we must, okay, we must multiply this in, distribute it, and then combine items on the top. Again, do not cancel this and that. It's a super common mistake that I see a lot of calculus students still make too. Okay, on the top, we actually just have, let's see, if I multiply this out, we'll just have negative 2x. Sometimes if you want to just do some scratch work, just put on the result on the top. Negative 2 times x, and then negative 4. So we see this is 3x minus 2, which is just an x. Yeah. So on the top, we actually have x minus 4. Yeah. Over 3 times x minus 4, and then x plus 2. And we see that this time, x minus 4 can be cancelled out with that x minus 4. So the answer is 1 over 3x plus 2. Okay? Again, Do not look at the parentheses and be too happy and just cancel them out. It happens a lot, and I'll tell you guys when will happen once you end up with this kind of expression. But that's it for number 13. Number 14 is perhaps my favorite for this worksheet here, because not only I came up with it, but it's so beautiful. Let me show you. We have 11x minus 3. So far no parentheses, but you know the parentheses will be coming here, and then we have x plus 2, or x squared plus 2 here. Over, on the bottom, guess what? We have 11 parentheses and then x minus 3. And then parentheses x squared plus 2. Wow, you see the top and the bottom, they're actually pretty much the same, huh? Except for this part here does not have the parentheses, but this part does. Be super careful with this. On the bottom, this times that, so it's already factored for us. But on the top, you see that we have 11x minus 3 times the parentheses x squared plus 2. We will have to take this and distribute it inside combined terms before we can do a thing, alright? So do not just cancel everything and say the answer is 1 or 1 not. Don't do that. Check this out. Negative 3 times x squared, well, that's the x squared term, so I'm going to write that down first. Negative 3x squared. And then I'm going to put down the plus 11x. Then we have negative 3 times 2, which is negative 6. And over the denominator, 11 times x minus 3, and then x squared plus 2. Can we simplify this? You bet. I set this up, so of course we can do more and then cancel things out. So right here, I will tell you though, we see that we have a negative 3 in front of the x squared. Usually we like to keep the x squared term positive, so let's go ahead and just factor out negative. So negative, and then we get 3x squared, change this to a minus, and then change this to a plus, because we took out the negative at the front. And then if we look at this, let's see, we can do the tic-tac-toe right here. 3x squared minus 11x plus 6. Just go ahead and do it. Tic-tac-toe in action. 3x times x, that's the only way. Yeah. And then right here, negative 2, negative 3. Let's put on negative 2 here and negative 3 here. It works. This times this is negative 9x, and this times this is negative 2x. Together, we do end up with negative 11x. So here, at the top right here will be negative. The factoring is 3x minus 2. Yeah, 3x minus 2 times x minus 3. See? Okay, over 11 times x minus 3, and then x squared plus 2. And we see that this and that cancel, so of course that will be the final answer, and we can just leave it like that. You don't have to distribute the negative, just leave it like this. And if you want to put that at the front, well, in the middle of the fraction part, that's okay too. But negative parentheses 3x minus 2 over 11 times x squared plus 2. So this is it. Yeah. Alright, number 15 is also one of my favorites. Let's see. Number 15, we have 3x minus 5 times x plus 3, and then plus 11 over, here we have 3x minus 8 times x plus 3, and then plus 14. Hey, you see that the x plus 3 cancel them? No, don't do that, because again, the plus 11 here, likewise the plus 14 here, right? So in this case, we really just have to multiply things out and then combine terms, all that. And yeah, it's not like a nice factoring, so we cannot do the difference of 2 squared unlike question number 12. So let's just go ahead and multiply things out. So this times this and all that stuff, right? So let's see. I'm just going to work it out along the way for you guys. 3x times x is 3x squared. And then this times this, the outer term is 9x. And the inner term right here, negative 5 times x. Together, we end up with plus 4x. And then this times that is minus 15, okay? And then we have the plus 11. Over, do the same thing. This times that is 3x squared. And then this times this is 9x. And then this times this is negative 8x. So together we have plus x. And then negative 8 plus 3 is negative 8 times negative 8 times 3 is minus 24. And then plus 14. Yeah. Alright, and then just continue. And notice that this is just pretty much minus 4. Right? So on the top is just 3x squared plus 4x. And then minus 4. And on the bottom we have 3x squared plus x minus 10. Okay, let's just go ahead and factor it. So let's see. On the top here, we have 3x squared plus 4x minus 4. So let's put down 3x and x. And then let's try 2 and negative 2. And we want a positive 4 right here. So this should be negative. This times this is 6x. This times this is negative 2x. Yes, it works. So the top is 3x minus 2 times x plus 2. Yeah, so the original versus the simplified version, they look kind of different, huh? Okay, and then on the bottom, let's just go ahead and do this. 3x squared plus x and then minus 10. Again, factor this. Now, we'll just keep the same colorway. Let's see, this is 3x and x. To get negative 10, we need 5 and 2, and one of them should be negative. Let's put down 5 here and 2 here. We need 5 to be negative because this times this is 6x, this times this is negative 5x. Together, we do end up with x. So the bottom is 3x minus 5 times x plus 2. And you know it, x plus 2 cancel, so the answer is 3x minus 2 over 3x minus 5. Done. Cool. I came up with this just to let you guys know. Yeah. Okay, number 16. And once you guys look at these right here, from number 16 to number 20, yeah, they are from the so-called definition of derivative. And it looks like this. The ones with h. First, we have negative 1 plus h squared, and then minus negative 1 plus h, and then minus 2, all over h. For this kind of questions, our goal is just to multiply out, well, open the powers and all that, and then combine terms, and then somehow we're going to factor and cancel the h. You'll see. First, let's do this right here. Okay, this right here is negative 1. Square that, we get 1. And then 2 times this and that, that's negative, so it's minus. And then we have 2h. And then lastly, h squared. Yeah. And if you would like, you can also reverse the order h minus 1, but later on in calculus, or if you're in calculus already, you know exactly why this is in this order, because the definition of derivative is a plus h, you know, stuff like that. Anyway, okay, so that's done. And then for this right here, just distribute the good away, so we get plus 1 minus h, and lastly we have the minus 2 all over h. Now we see that 1 plus 1 is 2, minus 2 is 0. And as you can see, this, and that, they all have an h, so we can factor it out. And notice that we can actually, let's combine them first. Yeah. So in fact, we have negative 3h plus h squared over h, and then we can factor out the h. And then this is negative 3 plus h only over h. Yeah, and then cancel, Final answer, negative 3 plus h. Done. Yeah, just like that. Okay. All right, it's 1:45 a.m. Okay, just to let you guys know. Okay, number 17. Whew, it's like a lot of extreme algebra problems, you know, just like multiply things out, work it out. Okay, 3 times 5 plus h squared, and then minus 2 times 5 plus h, and then minus 65. Everybody over h. Let's just go ahead and get to work. So multiply this out. Let me just put on the result right here because we have the 3 at the front, right? So 5 squared is 25 plus 2 times this and that, which is 10h, and then we have plus h squared. So we take the 3 distribute. 3 times 25 is 75. And then 3 times 10h is 30h. And then 3 times h squared is 3h squared. And for this right here, just multiply it out, we get negative 10 and then minus 2h. So just be super careful with not making careless mistakes, right? Minus 2h. And then lastly, we have the minus 65 all over h. All right, now check this out. 75 minus 10 is 65, and then minus 65 is 0. So this, and that, they all cancel each other out. And then we see that this and that is 30h minus 2h is 28h. So we can write it as, well, 28h, that's factor on h. So just be 28. So we save a step right here. And then we took out the h, so this right here is 3h all over h. H cancel, so we just have 28 plus 3h, just like this. Yeah. So let me just tell you guys this real quick. Sometimes we may make like small mistakes or careless mistakes, like what I was doing earlier, right? Forgot a number or like added wrong, subtracted wrong. In the learning process, it's okay, as long as you know what to do. That's the most important part. And then I might make a lot of mistakes here. The reason is because, why am I doing this in the midnight? I don't know. No, I know the answer because I don't really have time in the mornings and all that stuff. And yeah, anyway, let's just continue. All right, for number 18, let's just have more space so I'll be happier. So let me just erase this. Right, number 18, crazy equations. It's not just with h, but also x. So x and h together. First, x plus h square, and then minus 7x plus h, like this, and then minus parentheses x squared minus 7x. And you know it, all over h. Alright, let's just go ahead and get to work. So for this part, it's not bad. We can just multiply it out, like how I showed you guys earlier. So x squared plus 2 times this and that, which is 2xh, and then plus this thing squared, so plus h squared. For this, distribute it, so we get negative 7h, and then negative 7x, and then minus 7h. And then for this right here, just distribute it, right? Distribute it, so we get negative x squared plus 7x. Everybody all over h. Now, happy canceling. X squared cancel. Negative 7x plus 7x cancel. Very, very nice. That's about all. And for the remaining things, everybody has an h, so let's factor it out. So we have the h, and then 2x from here. This is h squared, took on h, so it's just h. And then the h is out, so we have the minus 7 all over this h. And the h cancel. So 2x plus h minus 7, done. Okay, the questions is actually getting bigger and bigger. Because when I was coming up with these questions, yeah, I still want to increase the difficulty. Yeah, to entertain not only for myself but also try to entertain you guys. So I need to erase this again. All right. Number 19. Crazy questions. It's October, so Halloween's coming. Anyway, number 19. First we have 3 plus h to the third power, and then minus 2 times 3 plus h squared, and then plus 3 plus h, and then finally minus 12, like this, all over h. Here we go. This right here has the third power, so it's your call if you want to write it down 3 times and multiply things out, or use the formula I showed you guys earlier. I will use the formula I showed you earlier. If you want to multiply it out, just do it on your own and then try to see your answer is the same as mine. Firstly, I'm going to take the 3 and then cube it, which is going to be 27. Next, we are going to add the coefficient 3 times 3 squared, which is 9. So 3 times 9 is 27. And then we have to introduce the h. Then the coefficient is 3 times 3 to the first power, which will give us 9. And then introduce the h again, so h squared. Lastly, h to the third power. Okay? And then for this right here, when we multiply this out, we get 9 plus 6h plus h squared, and then multiply out the negative 2, right? So we get negative 18, and then minus 12h, and then minus 2h squared. And this right here, the parentheses doesn't matter. So plus 3 plus h. I will change it to red so that it's easier to see. This right here is just plus 3 plus h. Finally, we have that minus 12 all over h. Okay, you know the deal. Blue pen. Let's see. 27 minus 18 is 9. 9 plus 3 is 12. Minus 12 is 0. So in fact, this cancels out with this, that. Perfect. And then we can combine all the h's terms as well, right? So this is 27h minus 12h, and then plus 1 more h. So let's see. Let's factor out the h, and let's see how many is that. 27 minus 12 is 15, plus 1 is 16. And then the h is out already. And then next we have the 9h squared minus 2h squared, but we took on h already. 9 minus 2 is 7, so this right here is plus 7h. And lastly, we have the h to a third power. We took out one of them already, so this is plus h squared all over this little h. Cancel, cancel. 16 plus 7h plus h squared, and we are done. And of course, if you write it down the other way, it's okay too. Yeah. And in fact, in calculus, once you have all this right here, you are going to plug in h equal to 0. Yeah. So if you have seen that part already, yeah, you know you are doing the derivative. Yeah, especially with the definition. Yeah, a lot of this right here just from there, and then that's one of the first few things that you guys will do in calculus, and yeah, a lot of algebra, I'll tell you. Number 20, perhaps the longest, well, definitely the longest one right here. Okay, number 20. Here we have 4 times x plus h third power minus 3 x plus h, and then minus 9, and then minus a big parentheses, and then here we have 4 x to the third power minus 3x and then minus 9 all over, you know it, h. Okay, let's multiply this out. Wow, and then we have a 4 at the front. So I'm going to put on the result on the top. So we get x to the third power plus 3x squared h plus 3xh squared plus h to the third power. It's just a formula I told you earlier with the x and h instead of a and b. Alright, and then put the 2 and distribute the 4 into all the terms inside. So we have 4 x to the third power plus 12x squared h and then plus 12xh squared and then plus 4h to the third power. Whew. And then for this right here we have minus 3x minus 3h and then minus 9. Minus 9, let's just alternate the colors. So minus 9. And then distribute the negative, so we have negative 4x to the third power plus 3x and then plus 9. Right? All over h. Okay, blue pen time. Let's see. 4x to the third power cancels out with this negative 4x to the third power. Minus 9 plus 9 also cancel out. Oh, negative 3x, what are you doing here? Right? Cancel them out. Good. Okay, that's about all. Let's factor out the h then, huh? So we have h, and then right here this is 12x squared plus 12x, and then one more h, and then plus 4h squared, and then minus 3, right? Yeah, and then all over h, and then cancel this out. Yeah, so 4h squared, 12xh, yes. Yeah, so I'm just going to leave it like this. 12x squared plus 12xh plus 4h squared minus 3. Alright? Yeah. And the reason I have the answer is because sometimes, especially later on, you don't know when and you don't know which formula you want to stop. And I'm going to, if I want to give this as like a quiz or test to my students, I will make this into like multiple choice format. Like I give you a huge algebraic expression and I'll give you like 3 or 4 answer choices. You just have to do enough algebra work and make sure your answer matches with one of the answer choices. All right. So 20 questions, not so bad I would say. Okay, let's check this. Good. Number 21 to number 30, we are talking about expressions with square roots. So this is the time that we are going to use the so-called conjugate. And the idea is that whenever we have a minus b times a plus b, this right here we actually have seen earlier. It's just pretty much the difference of two square formula, but you look at it backwards. It's a multiplication version if you go from here to here. The idea is that if you have a minus b, this term, and if you multiply this by, it's kind of like the opposite, huh? Right? This is the so-called conjugate of that. You just change the negative to a positive and you keep the a and b. The good thing about this is that you get to just square the first term and then minus the square of the second term. And that is how you cancel out the square roots. So let me show you. Number 21. We have square root of, just kidding, square root of x minus 8 over x minus 64. So whenever you have square roots, especially two terms, right? Because this is one term, and then we use the plus or minus to separate terms. So one term, two terms, and then one term, two terms. So we have a square root, we will use the conjugate. Well, we will keep this, so we have square root of x, and then you change the minus to a plus. So we add, and then the 8 stays. So that's what we do. Likewise, we do the same thing on the bottom. So square root of x plus 8. Okay, and then for the top, to multiply this out, just use the formula. Namely, we go ahead and look at this, square that, square root of x squared. Square root of x squared is just x. So we have x right here. And then minus 8, and you square that, which is going to give us 64. Just like that. And on the bottom, don't multiply it out. Wait for good things to happen. The cancellation. You see here, we have x minus 64 times square root of x plus 8. Yes, this and that cancel out. How cool is that, right? And then we get 1 over square root of x plus 8. So the original can be kind of reduced to this. Yeah. And in calculus, when you have square root in the denominator, it's totally okay. And we're all adults now once we get to calculus. Yeah. Okay, so that's that. Okay, number 22. So the expression gets a little bit longer, but same thing. Square root of 2x plus 9 minus 5 over, we have 2x minus 16. Alright, so fix a square root by using the conjugate. So let's multiply this by square root of 2x plus 9. Change the minus to a plus and then keep the 5 like so. And then for the bottom, just leave it. Square root of 2x plus 9 and then do the same thing, plus 5. Yeah, just multiply out. And notice that this is 2x minus 16. We can factor out 2. So don't multiply out, but if we can factor it, try to factor it. Okay, on the top, square this, we just get 2x plus 9. And then we minus the 5, we square that, which is 25. Over. Actually, no, I take it back. Yes, you can factor it, but 9 minus 25 is minus 16. The top is actually very nice, 2x minus 16. So let's just leave it like this, 2x minus 16, and then all this stuff, right? Square root of 2x plus 9 plus 5. This and that cancel out. So the answer, the simplified version, 1 over square root of 2x plus 9 plus 5. Yeah, just like that. You guys can count how many times I erased the board, like from, just like have a blank board. Yeah, this is like this is definitely the most tiring thing when I do the marathon videos. Okay, I'm not complaining. Well, I am complaining, but I will try not to complain. Okay, number 23. We are looking at 2x minus the square root, and then we have 3x plus 10 over 2x minus 4. Ooh, 2x, but cannot do anything, right? But we do have the square root, so let's use the conjugate. So here, let's multiply this by 2x plus the square root. So 3x plus 10, and then the bottom, let's go ahead and do the same thing, 2x plus square root of 3x plus 10. On the top, when we multiply this out, we just square the first term. So 2x, square that, we get 4x squared. And then minus square root, square, they cancel, so we just have the inside. So put parentheses though, because we have a minus. We have to distribute that. So this is 3x plus 10. Yeah, and then for the bottom here, I'm going to leave this like, but we can factor out 2, so let's factor out 2. So right here, I'm factoring out 2, and then we have x minus 2, and then all this stuff, right? So 2x plus square root of 3x plus 10. Yeah, and then notice the top is what? We can distribute the negative, so we really have just 4x squared minus 3x and then minus 10. Okay, factoring again, right? So let's see, 4x squared minus 3x minus 10. Let's do the tic-tac-toe factoring right here real quick. So let's try 2x and 2x. Is that going to work? 5 and 2. 2 times 2 is 4. 5 times that is 10. So it's not going to give us -3. So let's try this with 4 and x. Yeah, 4x and x. And then 5 and 2. One of them should be negative. Let's put on 2 here and 5 here because make this negative. This times this is negative 8x. This times this is 5x. Aha, it works. So the top right here factors to be 4x plus 5. And then x minus 2. Aha, see? Yeah, of course, a lot of these questions are set up so that they can have the nice cancellations. But you have to keep in mind though, not all the time they have cancellations. Yeah. But of course, only the ones with like beautiful cancellations are the fun ones. So anyway though, 4x plus 5 over 2 at the front and the parentheses 2x plus square root of 3x plus 10. Done, just like that. Oh my goodness, I just realized that the expression gets bigger and bigger again, so I will have to erase this one more time. Number 24. So here we have square root of 3x minus 2 minus square root of x plus 16 over the bottom is 4x minus 36. This time we have 2 square roots, but still same thing. Let's do the conjugate. So right here, let's multiply this by square root of 3x minus 2 plus square root of x plus 16. So let's go ahead and do this. Square root of 3x minus 2 plus square root of x plus 16. Okay. We are going to square that, which is 3x minus 2. And then minus square that, so just parentheses, okay, x plus 16. And then the bottom. So keep it. So here, let's factor out 4. 4 and then x minus 9. And then this right here is square root of 3x minus 2 plus square root of x plus 16. On the top, it looks like we can do something, huh? Yeah, definitely. Let's go ahead and do that. So this is 3x minus x, which is 2x. Negative 2 minus 16 is minus 18. Yeah, minus 2 minus 18. And then we see that 2x minus 18, we can factor out 2. X minus 9. Aha, this and that. Nice. This and that. Cancel out very nicely. Moreover, 2 and 4 can be reduced. So we have a 2 right now. Yep. So ladies and gentlemen, on the top we just have 1 over 2 times square root of 3x minus 2 plus square root of x plus 16. Done. So it was after the reduce. Yeah, just like that. Okay, I have to erase the board again. Alright, now expressions with x and h again. Number 25. Here we have square root of 5 parentheses x plus h and then plus 2 minus square root of 5x plus 2 over our favorite letter in calculus, right? H. Okay, so again, same thing. Let's multiply the top and bottom by the conjugate, namely square root. And of course, let's just multiply this out, right? So that's 5x plus 5h and then plus 2. And then this right here, just put it as plus, and then square root of 5x plus 2. And then of course do the same thing on the bottom, 5x plus 5h plus 2, and then plus square root of 5x plus 2. Okay, so multiply this, and you might be wondering, do we really have to show the work right here, right? Well, I will tell you, if this is like the first few times that you are doing this, then definitely you just show work to keep track of everything. Maybe we can try the next one that we don't show work. Yeah, but let's see. We are going to just square this, which will just have the inside, and that will just be 5x plus 5h and then plus 2. And then minus the second term, which is 5x plus 2. Yeah, all over all that stuff. So h times square root of 5x plus 5h plus 2, and then plus square root of 5x plus 2. Now, let's see. We can distribute this as negative 5x minus 2, but the 5x minus 5x cancel, and this and that cancel. On the top, we just have 5 times h. Well, this h can be cancelled out with that h. So ladies and gentlemen, the answer for this right here, I will just write it down right here. We have just a 5 on the top over square root of 5x plus 5h plus 2 plus square root of 5x plus 2. Yeah, who came up with all these kind of expressions? Well, definition of derivative. And of course, I did come up with them too. But anyway though, number 26. So here we have square root of parentheses x plus h square, and then minus 6, and then minus square root of x squared minus 6 all over h. Alright, so we did the 5 conjugate earlier already. I showed you guys the work. So for this one, let's see. We know that we will have to multiply the top and bottom by this, but you just change the minus to a plus, right? So let's not show work anymore. And you know what's going to happen is that we square this, which is square, and also the square root will cancel. Square and the square root will cancel, so we just have the inside. And for this right here, let's just multiply it out, and that's x squared plus 2xh plus h squared, and then minus 6. And then we minus the square of this term, which is just going to be x squared minus 6. And then for the bottom though, well, we will have h, and now let's write down the conjugate, and that's square root of x squared plus 2xh plus h squared, and then minus 6, and then plus square root of x squared minus 6. Okay, I don't know why I'm laughing, but like, yeah. Anyway, this is negative x squared and then plus 6. Cancel, 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 cancel. This and that, they both have h. Let's factor it out. And then we get 2x plus h. Yeah? And then this h and that h cancel. So finally, ladies and gentlemen, we get 2x plus h on the top over that big long conjugate. So x squared plus 2xh plus h squared minus 6, and then plus square root of x squared minus 6. So let me just make it prettier for you guys. And then 2x plus h right here. Yeah, okay. So for the remaining question, I'm just going to not do the conjugate, just so that way we can save some time of writing. A lot of this is just really just because we have to write a lot of stuff down, and sometimes it's the same thing, the same expressions over and over, so that's why it seems really long, especially if the question is really long already. Then yeah. I really want to tell you guys, like, this right here is actually not so bad, right? Calc 1, Calc 2, not so bad. Wait for differential equation. Yeah, and then if you don't like computations, if you think computations are not that challenging. I would say if you think computations are not that challenging, then try to take a proof class analysis. Yeah, that would really like work out your brain. Okay, number 27. What's analysis? Adult version of calculus. Yeah, square root of x squared plus 7 minus 4 over, on the bottom we have 3x minus 9. You know the deal. Multiply the conjugate on the top and also on the bottom. First we square this, right? So we just get x squared plus 7 minus, we square that, which is 16, over, we can factor this out, right? Factor out the 3, like this. And then the conjugate, don't forget, right? So we have the square root, x squared plus 7, and then plus 4. Yeah. On the top, this is what? X squared minus 9. So we can actually factor it as x minus 3 times x plus 3. And we see this and that cancel out very nicely. So we just get x plus 3 over 3 times square root of x squared plus 7 and then plus 4. Done. Okay, number 28. Alright, we have a square root on the top. 5 minus square root of x squared minus 11 over 3 minus square root of x plus 3. Yeah, square root on the top and also a square root on the bottom. So just kind of keep track of what we are doing and all that stuff. So let's see. Square this minus the square of that, right? So we will first have 25 minus the square of this, which is just x squared minus 11. And we should have its conjugate on the bottom. So I'm going to put down its conjugate right here. And that is 5 plus square root of x squared minus 11. Because we technically multiply the conjugate on the top and also on the bottom. But this right here also requires the conjugate, huh? So I'm going to square this, which is 9, minus the square of that, which is x plus 3. And this right here is a term, so I shall put this in the parentheses. And on the top right here, we also need its conjugate, and that's 3 plus square root of x plus 3. And this right here, because we multiply this on the top, so this right here also needs a parentheses. So it's like that. Yeah, pretty crazy stuff, I know. Okay, this right here, okay, so this is negative x squared and then plus 11, so it's plus 36. Okay, so yeah, and then this right here is negative x, and then this is 9 minus 3, so 6 minus x. You know what? I'm just going to keep it like this. This is 36 minus x squared, which is the difference of two squares. So we can factor it as 6 minus x times 6 plus x. Because earlier this was 36 minus x squared, so we factor it. Because now we see that they match exactly, so we can just go ahead and cancel them out. Yeah, and that's it. Do not multiply the conjugates anymore. We have some cancellations, we should be happy with it. And we'll just write down the answer. And right here on my answer key, I wrote here 6 plus x. But let me write it as x plus 6. Yeah. Yeah. Usually we like to have the x go first. And if it's a plus, the order of addition doesn't matter. So x plus 6 and then all that stuff. So 3 plus the square root of x plus 3 over this guy, which is 5 plus square root of x squared minus 11. Whew. Oh my goodness. Yeah, just like that. Okay. Okay, number 29, we have a square root inside of a square root. So we need some conjugates, of course. All right, so it looks like this: square root of 5 plus the square root of x plus 6. And then outside here we have the minus 3, and then all over x minus 10. Okay, I'm going to multiply the top and bottom by this conjugate. So it's this plus that. First I will square this, so I will just get 5 and then plus square root of x plus 6. So pretty much the outer square root get cancelled, and then minus the square of that, which is 9. And then the bottom here we have that x minus 10, and don't forget we need that conjugate, right? So that was the big square root and then 5 plus the small square root x plus 6, and then change the minus to a plus, and we have that 3. So it's like that. And notice though, 5 and minus 9 is minus 4, right? So we have this minus 4, and that's a square root expression, so we need a conjugate again. So I'm going to just square that, which is x plus 6, or x plus 6, and then minus 4 squared, which is 16, like that, over, okay, we have that x minus 10, the first conjugate from the first expression, which is the square root 5 plus the square root of x plus 6, and then plus 3. And then earlier we also need that conjugate, and that is going to be square root of x plus 6 and then plus 4. Yeah. And you know, I would like to write it down better for you guys. Here it was x plus 6 and then minus the 4 square, which is 16. Now 6 minus 16 is minus 10, so this is just x minus 10, but we see it, x minus 10 cancel out very nicely, so we just have that. So finally we have 1 over big square root 5 plus small square root x plus 6 and then plus 3, parentheses, another parentheses, square root of x plus 6 and then plus 4. Whew. Yeah, so just like that. Okay, number 30, it's similar. I'm gonna fit in here. No, it's going to be too painful if I fit number 30 here too. So I'm going to just erase this. Okay, number 30. Square root of 13 plus square root of 5x minus 11. Alright, so this is called the nested square root. So a square root instead of another. And then also here we have the minus 4 and all over x minus 4. Alright, so similar question, let's do it again. So first, multiply the top and bottom by the conjugate. So I'm just going to square this, which is 13 plus square root of 5x minus 11, and then minus this square, which is 16. So that's what we have. And then over here we have that x minus 4, and then we need that conjugate right here, and that's going to be square root of 13 plus square root of 5x minus 11, and then my plus 4. Okay, now we see that these two numbers can be combined. 13 minus 16 is minus 3, so we need the conjugate for this, right? So that's going to be what? 5x minus 11 and then minus 3 squared, which is 9. And then on the bottom here we have x minus 4 times this thing. So square root of 13 plus square root of 5x minus 11 and then plus 4. And then the conjugate, which was square root of 5x minus 11 plus 3. Okay, on the top, this is 5x minus 20, which we can factor 5. That's x minus 4. Can anything cancel? Yes, x minus 4 cancel out. Very nice. So finally, we have 5 over this thing. So big square root is 13 plus a small square root 5x minus 11, and then plus 4, and then the square root 5x minus 11, and then plus 3. Ooh, look at that. And the box the answer. And then hit the board. Okay. So that should be enough practice with the conjugate business. So the second sheet, done. All right, let me take a look. Good. So it looks like, so far, each question takes about like 3 minutes, while maybe the erasing the board takes like about like a minute or two. No, not really, like 10, 12, 20 seconds. But let me tell you, the last 10 questions are the killer. Partial fractions, they are the killer. Anyway, next, we are going to do the so-called complex fractions. Complex fractions just means that we have small fractions instead of big fractions, and I'll show you guys the best way to simplify it. Number 31, I'm going to give you 1 over 3x plus 2 minus 1 over 5. Oh, see, one little fraction, two little fractions instead of a big one, like this. Yeah, so how do we take care of this? All right, pay attention to the small fractions, especially the denominators. They don't have anything in common, right? 5 and 3x plus 2. Then in that case, just multiply the top and bottom by the lowest common denominator. So that would just be 5, and then 3x plus 2. And then, of course, let's do the same on the bottom. So this is what we will have to multiply when we have a complex fraction. And then just be really careful. Take this times that, the 3x plus 2 will cancel, so we will have the 5 first. And then minus 1/5 and 5 cancel, and we have that, which is 3x plus 2. On the bottom, let's just rewrite everything again. So we have the 5, but the x squared we can factor it, so let's go and factor it. So x minus 1, x plus 1. So this is from here. And then we have that 3x plus 2. And do you guys notice that this is very similar to when we were talking about expanded and cancel? You see the 3x plus 2, 3x plus 2, they are both in parentheses. Can we cancel that? No, because right here we have the 5 minus that. So we have to work that out. We have to combine them. Okay, so this is 5 minus 3x minus 2. So that's going to be 5 minus 2 is 3, right? So this is, let's just write it as 5 minus 2 is 3. So let me just put it down like this. Yeah, and notice this is negative 3x plus 3. We can factor out negative 3. And then that will give us x. But originally here wasn't positive 3. We took out negative 3, so this is minus 1. So that will be the simplification on top. So just make sure that you really work out the top and then simplify it. Then the x minus 1 can be cancelled. Very cool. Right? So finally, we just have the negative 3 on the top over, this is 5 times x plus 1 times 3x plus 2, and then we are done. And hit the board, of course. Number 32. All right, x over x minus 3, and then minus 2 over x minus 6. So similar thing, let's go ahead and just multiply the top and bottom by, well, this is just a 2. So we just need that, namely x minus 3. X minus 3. Okay, when we take this times that, they cancel, so we just have x first. And then we have the minus. Here we have the 2. We will have to multiply by x minus 3, right? This times that. And then the bottom, just leave it. So here we have parentheses x minus 6 times x minus 3. Again, do not cancel this and that. I know they are both in the parentheses, but we really have to work it out first. So this is x minus 2x plus 6. Yeah? And then this is actually just negative x plus 6. Okay? So this is negative x plus 6. This is 6 minus x. This is negative x plus 6. This is x minus 6. What can we do? Well, this right here is equal to negative x minus 6. We can factor our negative, right? And then this x minus 6 and that x minus 6 can be cancelled very nicely. So we have a negative on the top over x minus 3. So that will be the final answer. Negative 1 over x minus 3. And some people might notice sometimes if they want to put a negative on the bottom, they can do this. I'll put this down in blue. If you want, you can put a negative on the bottom, becomes negative parentheses, and then x minus 3. You can distribute it. You can 1 over negative x plus 3. You can change the order as 3 minus x. Or another way to look at it, reverse this order, you get a negative. Negative cancel out with negative. You get 1 over 3 minus x. So this or that. Yeah. Usually we like to have the x goes first. Usually. Like most of the time actually, not just usually. Okay, so that's number 32. You guys notice that I do have a drink ready over here. I will take a drink once we finish the complex fractions. Number 33. So number 33, we have x over x plus 4 minus 1 over 3 and over x minus 2. All right, let's go ahead and get to work. Multiply the top and bottom by this and that, so 3 times x plus 4. Alright, so multiply this by 3 times x plus 4. Take this times that, the x plus 4 cancel. 3x goes first. And then, let me just write it down right here. This right here equals 3x. Leave some space so that you can do some computations above it. Easier that way. And then minus 3 and 3 cancel, right? And then we just have the x minus 4, x plus 4, sorry, yeah. All right, and then right here, let's just put a 3 first, and then x minus 2, and then x plus 4. So you see, once you simplify these complex fractions, this kind of expressions that we saw earlier just shows up naturally, like this and that. But don't cancel them out, work out the top first. So this is 3x minus x minus 4, which is 2x minus 4. And you can factor out 2, so 2x minus 2. The x minus 2 cancel. So finally, we just have a 2 right here over 3 and then x plus 4. Done. Yay, I don't need to erase that. Number 34. The one with h again. Okay. Maybe no, never mind. I am going to need some space. Eight over 2 times x plus h, and then minus 3. And then minus 8. See, this is why I need a space. 2x minus, yeah, over h. Whew. Okay, here we go. Multiply this by this and that. So I'll put this down first, which is 2x minus 3. And then for this guy, let's just multiply it out, right? So that's going to be 2x plus 2h and then minus 3. And then let's go ahead and do the same thing here. 2x minus 3 and then 2x plus 2h minus 3. Take this times that, this and that cancel. So we have 8 times that, right? So perhaps I'll write it down right here. 8 times 2x minus 3. And I'll distribute later. Next we have the minus. This is the 8. So perhaps I'll put the 8 black from the original. And then we also have this 8. This times that, this and that cancel. So we have this, which is 2x plus 2h minus 3. I feel like working out my arm. Yeah, and then right here we have h times 2x minus 3 and then 2x plus 2h minus 3. Let's just go ahead and multiply this out. This is 16x minus 24 and then minus 16x minus 16h and then plus 24. And check this out. 16x minus 16x minus 24 plus 24. This is negative 16h left. This h can be cancelled out with that. So on the top we have negative 16. Wow. Over here we have 2x minus 3 times 2x plus 2h and then minus 3. Not bad, seriously. It's not so bad. It's just a lot of like variables that you have to just keep writing them. And you see it? I'm doing this with you guys, okay? Yeah, the main thing is how much are you willing to do for your own good, right? Number 35. X plus h over x plus h plus 1 minus x over x plus 1 over h. Alright, multiply the top and bottom by this and that, so x plus 1, x plus h. Okay, I will do one more of this, and then later on I'm just going to show you guys like what we do with the conjugate. We will skip this step, just do this in our head. Alright, so this is x plus 1 and then x plus h and then plus 1. Alright, cool. Take this times that, this cancel, so we actually have the original is x plus h times the x plus 1. Right? And then we have a minus, and then this and that cancel. We have the x right here times all that, so it's x plus h plus 1 over h, x plus 1, x plus h plus 1. Okay, let's just do it. This times this is x squared and then plus x, right? This times that, and then this and that is plus xh and then plus h. Distribute, we get negative h squared and then negative xh and then negative x. Yay! Because this, that cancel, x cancel. On the top we just have an h. Cancel them, but don't forget we have a 1 on the top. So ladies and gentlemen, it's 1 over x plus 1 times x plus h plus 1. Yeah, this is my workout of the day, or of the night. Yeah. Okay, number 36. This one looks crazy. 1 over x squared minus 1 over 16 over x squared minus 16. X squared minus 16, wow. But remember that, you see the x squared, it's on the bottom here for this little fraction. Likewise, this is also on the bottom for this fraction. We had to clear the complex fraction first. And to do so, we multiply the top and bottom by the lowest common denominator, which is 16x squared. And now this time, let's do this on our head. So you pretty much multiply this and that together. That's the trick, right? So 1 times 16 have 16, and then minus this times that, which is just x squared. Yeah? Over the bottom, you keep it. So you have the x squared minus 16, but you multiply this and that together, which is 16 and also the x squared, like that. And then the dot means just that we are multiplying. Okay? And you know what? You see it? 16 minus x squared minus 16. In fact, we can just change the order of the subtraction by just negate it. So it's a minus and then x squared minus 16. And we happen to be able to cancel this and that completely. So the final answer is negative 1 on the top over this and that, which is 16x squared. Done. Next, number 37. 1 over x squared plus 2x minus 1 over 3, and then over x minus 1. Alright, so I'm going to just multiply the top and bottom by the lowest common denominator. So it's going to be like this. To put this as 1 times 3 is 3, and then minus this times that is just that, which is x squared plus 2x. And then the bottom here we have the x minus 1. Actually, let's put that at the end. I'll put on the 3 first, and then that, which is x squared plus 2x, and then the x minus 1. And so that's what's the lowest common denominator. I'll multiply top and bottom by that. Okay, so how exactly do we do this? Well, distribute this, we get negative x squared minus 2x and then plus 3. We don't like to have this being negative, so let's factor out negative. So it's negative x squared plus 2x and then minus 3. So let's see. On the top here we have minus, and then we can factor this trinomial. This right here is just x plus 3 times x minus 1. Yeah, for this. And we notice that here we have the x minus 1, so we can cancel things out. And if you would like, you can also factor the denominator, because usually we just like to have the denominator being factored in. So I will do this, and then I will do this, and then we'll be done. So I will leave it as negative parentheses x plus 3 over 3x times x plus 2. Yay. Okay. So a lot of this seriously just take practice. And I believe you have all seen this kind of things before. So that's why I just want to tell you guys the things that you have to be really careful, because I know you know how to do the typical things. That's why we're going slightly faster than the integration video or like the derivative video. Oh yeah, number 38. Okay, number 38. Ready? The previous category was the conjugate with the square root. This category is the complex fractions. We have them together right now. 1 over square root of x minus 3. Sorry, minus 1 over 3 over x minus 9. Let's fix the complex fraction first. So here we will have 3 times 1, which is 3, minus this times that, which is square root of x, over this which is right here, 3 square root of x times that. And what do we do next? You know it. We are going to do the conjugate. But this right here, again, is kind of out of order. So let's fix the order first. So take out negative, and then we look at this as square root of x minus 3. And then do this conjugate. So here, the negative stays. So if you multiply this with the conjugate, you just square that, which is going to give us x, and then minus the square of that, which is 9. Okay? And then the bottom here, just leave it. 3 square root of x, and then x minus 9. But we need the conjugate that we multiplied earlier, right? So the conjugate of that, which is the square root of x plus 3. And we see it, this and that cancel. So finally, the answer is negative 1 over 3 square root of x times square root of x plus 3. Alright, so just like that. And again, just perhaps as a reminder, we multiply by the conjugate square root of x plus 3 here, and then the square root of x plus 3 here. And then this times that gives us this. Yeah, but sometimes it's okay to just go from here to here. Like you see earlier, if you just go from here to here to here to here, it's better than if you show all the work every single time. Yeah. Number 39. 1 over square root of x plus h, and then minus 1 over square root of x over h. Similar thing. Let's just go ahead and get to work. Okay, this and that, which is square root of x minus square root of this and that, which is x plus h. On the bottom, start with x. Sure, just that. So it's just h, and then square root of x, and then square root of x plus h. Right, this and also this and that denominator. Cool. Now we need the conjugate, right? So the conjugate is going to be, put a plus here. So let me just put that down. Perhaps that will be easier. H times the square root of x, and then square root of x plus h. And then the conjugate also will go on the bottom. Square root of x plus square root of x plus h. On the top, when we multiply by the conjugate, we'll just get the square of that, which is x, minus the square root of that, which is x plus h. Okay? So this right here is actually just x minus h. And we see that this and that cancel, and this is negative h. This h and that reduced to 1, yeah? But it's negative. And that's it. So negative 1 over all the stuff. So square root of x times the square root of x plus h times square root of x plus the square root of x plus h. Done. Yeah. And let me just perhaps make this more clear. Multiply the conjugate, right? That's what we did earlier. So that's how we were able to go from here to here, yeah? And then originally, we multiply the lowest common denominator. So that's how we went from here to here, okay? Yeah, so if you kind of skip some steps, like especially like the algebra steps, especially the steps that you have to write like very long, yeah, that would be much better. Number 40. Wow. Number 40. Okay, 1 over 2 plus the parentheses x plus h square, and then minus 1 over 2 plus x squared over h. Definition of derivative. That's why. Alright, anyway. So first thing first. multiply the top and bottom by this and that, right? So you know this times 1, yeah? So the first thing is 2 plus x squared and then minus this times that, which is going to be 2, and then open that. So we have x squared plus 2xh plus h squared, wow, over h. And then this denominator and also that denominator, and now open that, which is 2 plus x squared plus 2xh plus h squared. Okay. You can distribute it and then cancel, or 2 minus 2 you can also cancel like that. I think I'm just going to distribute to make it more clear for you guys. So anyway, 2 plus x squared, and then this is minus 2 minus x squared minus 2xh minus h squared. Yeah, and then I will cancel. 2 minus 2, gone. X minus x squared, gone. And then we have all this. But they have h, so we can factor that out. And then we have negative 2x and then minus h. Yes. This h and that h cancel. Yeah, I just want to match my cancellation with 2 marks. And that's it. Ladies and gentlemen, we have negative 2x minus h all over all that stuff. So 2 plus x squared times 2 plus x squared plus 2xh plus h squared. Whew. Okay, it's only 2 hours, that's good. I'm actually not charging my phone yet, and I'm going to wait for like my phone tells me that like 20% or 10% left, and I will charge, because I'm afraid if I charge the phone there'll be like snow noises in the background, and that's not good. Anyway, not sponsored by this drink company unfortunately, but it's pretty good though. Okay, earlier was complex fraction and we did the lowest common denominator. Right now we will do the lowest common denominator and combine fractions. So lowest common multiple for the denominator. So usually people just write it as LCD, and then we will combine the fraction. That's the category for this part. Combine. All right, number 41. So notice now we are just going to have 2 fractions. So here we have 1 over 1 plus 3x, and the other one is 1 over 1 minus 3x. So what we are going to do is just combine them, and to do so, you see they have the different denominator. Let's just go ahead and multiply this by this, which is 1 minus 3x, and likewise we do the same on the top. And then right here, let's go ahead, multiply this by that, 1 plus 3x, and of course do the same on the top. And then put them together. Because now they have the same denominator, we can just write it as 1 plus 3x times 1 minus 3x. And then the top right here is just 1 minus 3x plus 1 times that is just 1 plus 3x. And we see this and that cancel, and 1 plus 1 is 5. No, just kidding, 2. On the bottom, just leave it. You don't have to multiply out the denominator. So leave it as 1 plus 3x times 1 minus 3x. Yeah. If you multiply it out, it will look like this. 2 over 1 squared minus 3x squared, which is 9x squared. That's 3x squared. Yeah. So, yeah, one way or the other. Okay, that's number 41. Now, 42. 1 over square root of x plus 1 over square root of x plus 1. Alright, so for this, let's go ahead and just practice that. We know that this guy needs this and that, and this. The first fraction needs the square root of x plus 1 on the bottom, also on the top. The second one needs the square root of x on the bottom, also on the top, right? And let's just go ahead and kind of do this in our head, save us some energy from writing. So right here, I'm just going to multiply them together. So square root of x times square root of x plus 1. And you can just write it down like this. And then you do 1 times that, which is square root of x plus 1. And then we add it with square root of x, like this. And that's it. And you might be wondering, do you want to do the conjugate? Well, right here, the main thing is just to combine them. If you leave it like that, that's okay. If you did the conjugate, this is the reason why I said that if I test my students, I will make sure that I give them multiple choice questions for this. And that's why make sure you follow the answer keys so that you know, okay, just stop right here and move on. Yeah. If you did the conjugate, it's not going to be so nice, I don't think so, but let's try it. Square this, which is x plus 1 minus the square of that, yeah, and over this thing is square root of x plus 1, and then the conjugate earlier is the square root of x plus 1. It was a plus, right now it will be a minus, and the square root of x. And we see that, okay, this and that cancel, so we get this 1 over square root of x plus 1, and then square root of x plus 1 minus square root of x. If you multiply the top and bottom by the conjugate, yeah, so just like that. Okay, but right here, we'll focus on just getting the same denominator and then combine the fractions. I put this after the complex fractions. I was debating to see which one I wanted to put first, but I think this right here, it's a little bit more difficult because you cannot cancel things out right away. So that's why I put it after the complex fractions. But you'll also see the later on cases why it becomes more trickier. Anyway, number 43. Here we have 3x plus 23 over x squared minus x minus 12, and then the other one is plus 2 over x plus 3. All right, in this case, if you multiply this thing by x plus 3, and if you multiply this thing by this whole denominator, that's too bizarre, because in fact we can factor this out. So let's go and factor it. We get what? X minus x minus 4 times x plus 3. I don't remember what times 4 is equal to negative 12. Negative 4 times positive 3 is negative 12, and together we get negative 1. Yeah. So you see, we have the x plus 3 in common. So that means this first fraction is done. For the second fraction, we just need that x minus 4 on the bottom and also on the top. Okay? And then we see that we can put them together and we have x minus 4 times x plus 3. This thing stays the same, so let's keep it as 3x plus 23. And then multiply this out, of course, and that's a positive, so that's plus 2x minus 8. Can we cancel anything? Well, let's combine things first. This and that is 5x. This and that is plus 15. Yeah, and then we can factor out a 5. So 5, and then this is x plus 3. Aha! I told you I'd come with all these questions set up nicely, huh? X plus 3 cancel. So the final answer is 5 over x minus 4, and we are done. Yep, just like that. Number 44. So here we have 2 over x minus 6. And then the other one is minus x plus 20 over 2x squared minus 11x and then minus 6. This can be factored in. This time, let's just go ahead. You can do the tic-tac-toe on the side, but let's just try to see if we can do it. You know it's going to be that. Yeah, let's try x minus 6. So that means we have to have 2x. And then what else do we need? Plus 1. Does it work? Try it. That gives us 2x squared. And this is negative 12x plus 1x. That does give us negative 11x. Negative 6. Good. So this time though, we just need to come here for the first fraction and then multiply this by this, because that's what it needs. So 2x plus 1 on the bottom and also 2x plus 1 on the bottom, on the top. So we are looking at, this is 4x plus 2. Now, be really careful. We are subtracting this fraction, and technically there was a invisible parentheses like what I mentioned it like 2 hours ago. So distribute the negative, we will get negative, and then the, just write it down like this, negative x and then minus 20, right? So negative. And then the denominator, x minus 6, 2x plus 1. And now let's just fix the top. So this and that is 3x, and then this and that is minus 18, and then we can factor out 3. And then better yet, we can cancel out the x minus 6. So finally, guess what? We have 1, 2, 3. 3 over 2x plus 1. Done. Okay, I don't know why. I think I just like to write it big. I don't know why. I was hoping that I can finish this in like 4 hours. Why did I think that? Anyway. Number 45. We have x plus 1 over, and then we have x squared plus x minus 20, and then minus 1 over, and here we have x squared minus 2x minus 8. All right, so we're going to look for the lowest common multiple for the denominator. So let's go ahead and factor things out because we don't know if they have any common factor or not. So right here, if we factor it, we get x plus 5 times x minus 4. Yeah, and then for this, we get x minus 4 times x plus 2. Good. Now, the x plus 4 is in common. So for the first fraction, well, we need this, namely x plus 2. So we also come to the top and multiply x plus 2. And then for the second fraction, we need the x plus 5. So let's multiply here, x plus 5, and then x plus 5. All right. So we get x plus 5 times x minus 4, and then x plus 2. Okay, multiply this out, x squared. And then this is 2x, and then another x. So altogether is 3x. And then lastly, plus 2. Yeah. And then this is the minus. Right, so it's minus. So we have a, let me just write it down like this to make it more clear. So it's a minus and then the x. And then minus 5. All right, so just like that. Okay, so can we cancel out anything? Okay, let's see. on the top we get x squared, this and that is plus 2x, and then minus 3. Yeah, and then if we factor it, we get x plus 3, x minus 1. Unfortunately, we cannot factor anything. But do you guys notice? Well, unfortunately, we cannot cancel anything. But do you guys notice what's so cool about this? 1, 2, 3, 4, 5. Yeah. Oh, I come up with this question, by the way. Yeah, I did come up with this question. And then, yeah. How did I come up with this? I started with the answer that I wanted and I worked backwards. Yeah. Anyway, though, we'll just leave it like that. Sometimes, if nothing can cancel, just leave it. And this form is preferred, even though you're in if you're in pre-calculus, then you can use this form to make the graph for the rational function for you and all that stuff. But anyway, this is number 45. Number 46. Now you will see the question looks kind of weird. It's like, why did I just cancel them out at the beginning? The reason is because these expressions, they come from when we do the so-called derivative with product rule. Sometimes you just have to write things down and then you get like a long expression and just have to be really observative. Okay, this we can cancel, this we can combine, that's why. So I didn't make this up out of nowhere. That's what I'm trying to say. Number 46. We have x times 1 over 2 square root of 6 minus x. And then times negative 2x. Yeah, this is what I mean. Seriously, that's the expression. And then after that, we have the plus square root of 6 minus x squared. Oh, sorry, this right here is supposed to be x squared. Okay, so this is number 46. So let's see what we can do. First, if you look at this part, they're all multiplying. Of course, this 2 and that 2 can cancel. X times negative x, that goes to the numerator. So we have negative x squared over square root of 6 minus x squared. And then for this one, it's just square root of 6 minus x squared. How can we combine them? Well, this is kind of like saying over 1. So let's just go ahead and multiply the denominator by square root of 6 minus x squared, and then, yeah, so we can match with that. And then do the same thing here. So multiply the top and bottom by what we need here. Now they have the same denominator, and we will get what? Square root of 6 minus x squared. This is still negative x squared. But then if you see this and that, they multiply, you just get inside, which is going to be plus 6 minus x squared, yeah? Yeah, and then what can we do next? This and that can be combined, so we have, and now here's the thing. If the original expression, we have like minus x squared and x squared at the end, I like to keep it the same order. So I'm going to write it as 6 minus 2x squared over square root of 6 minus x squared. Yeah, so I think this is how people usually like to write it as well. So that's the reason. And that's it though. So even though we have the square root expressions, we can still get a common denominator and then we can still combine them together. And the reason that we want to combine this and that together is later on, we want to solve equation. We set this equal to 0 and then solve for x. Yeah, but we are just focusing on how to do the simplification. That's why I'm not continuing anything else. Number 47. Does my hair look okay? Alright, anyway. Number 47. We have x squared and then times 1 over 2 square root of 1 minus 8x times negative 8, and then plus square root of 1 minus 8x times 2x. Yeah, so this is the question. My handwriting is getting sloppy, huh? I'm sorry. It's 47, and then that. All right, let's just go ahead and simplify. This 1, and then this 4, yeah? So we can reduce that. That's about all. So the first part, we will have negative 4x squared over this for the denominator, so square root of 1 minus 8x. And then for this one, we'll just write this 2 square root of 1 minus 8x. And we just need this denominator here. So let's multiply the bottom by square root of 1 minus 8x, and then let's also do the same on the top. Now we can put them together. This is just square root, we keep the same denominator, 1 minus 8x, and then this is negative 4x squared. This times that, sorry, it's 2x. Sorry. Okay, this times that is just 1 minus 8x, right? The square root doesn't matter anymore. And then we'll take this multiplying. So we get plus 2x and then minus 16x squared. Yeah. And then finally, we'll just combine this and that together. And let's just put the x squared at the end. So ladies and gentlemen, we have 2x minus 20x squared all over square root of 1 minus 8x. Yeah. Pretty good answer, I would say. And we are done. Alright, number 48. Now the question may look like slightly, I don't know how to, let's just look at the question. Number 48. So here we have 3 over 4 x to the negative 1 over 4th power. So we have a negative exponent here, and then after that we have a minus 1 over 2, and then this is x to the negative 3 over 4 power. First thing first, negative exponent, we can just bring the x, right, this term down to the denominator. So the first one is really 3 over 4 x to the 1 over 4 power, and then minus the other one, 1 over 2 x to the positive 3 over 4 power, right? So now, what exactly do we need? Well, firstly, let's look at the number. This is 4, this is 2. We need 2 right here. So multiply by 2, multiply by 2. So we can get a 4. Now let's look at the x to the power. Ooh, which one's bigger? 3 over 4, of course. So what do we need? We need to have 2 over 4. So let's write it as x to the 2 over 4, and then x to the 2 over 4. I know 2 over 4 is the same as 1/2, but let's do that later. But this way we can see that they will both have the same denominator, namely 4, and then x, and then 3 over 4th power. Alright, now here we have 3, and then this is just x to the 1 over 2 power, isn't it? Namely square root of x, and then minus 2. Yeah, so that will be it. Yeah, well, I'm going to fix my answer key. This is a much better answer. Yeah, that's it. Yeah, you don't need to multiply the conjugate. If you want, I'll leave that to you. Okay, again, the reason that we combine the fractions is because we are going to set this to be 0 and then solve for x. So now we can just put the top to be 0 and we can go from there. Yeah, but I'm not going to do that because, again, we're just looking for the simplification and all those things. Number 49. Whew, a long expression is coming. So let's see. Number 49. We have x to the 2/3 power times 1/3 and then 10 minus x raised to the negative 2/3 power and then times -1. I didn't make this, well, I did come up with this question, but they came from different, they came from derivative by power. They came from derivative by product rule and also the chain rule. But anyway though, and then after that we have a plus 10 minus x and raised to the 1/3 power times 2/3 x to the negative 1/3 power. Yeah. So I would recommend you guys to do the following. So once you write this down, right, we see negative exponents, let's just take care of that. And then let's just see. So this right here can go down to the denominator and we have a negative times that. So the first part is going to be negative x to the 2/3 power over 3 on the bottom. Likewise, 10 minus x to the positive 2/3 power now. So that's the first part. And for the second part, we add 2 on the top, well, 2 and that on the top, so 2 times 10 minus x to the 1/3 power, and 3 on the bottom, and this is x to the positive 1/3 power on the bottom. So that's what we have. Now the question is, how do we combine them, huh? Well, let's see, they both have 3, that's good. This part does not have x to the 1/3 power, so we need that. So multiply by x to the 1/3 and then multiply by x to the 1/3. This part does not have that, so I'm going to multiply by 10 minus x to the 2/3 on the bottom, and then of course do the same on the top. And you can see that it's actually working out really well, because after they have the same denominator, which is just 3 and then x to the 1/3, and also 10 minus x to the 2/3. Okay, this is just what? 2/3 plus 1/3 is just 3/3, which is just 1, right? We multiply them, we add the exponents. So it's just x to the first power, namely negative x. So we have negative x. All right, now this times that, 1/3 times 1/3 power and that power, again, they add up to be just 1. So it's just this. So right here, we just have to add 2 times 10 minus x. Yeah, it works out so nicely, right? Okay, and then let's see. This is just negative x and then plus 20 and then minus 2x. That's about all. Cannot really do anything else. So I will just write it down. 20 goes first, minus 3x, because originally we have the minus x at the end, right? So I also keep the x at the end. And then here we have the 3x to the 1/3, 10 minus x to the 2/3. Yeah. Huh? I think it's pretty cool. Yeah. Okay. Don't worry, I have another one that's kind of similar to this. Alright, number 50. Here we have x to the 4/5. 4/5. And then times 2, parentheses x minus 4. Like this. And then after that we have plus, parentheses x minus 4. square and then times 4 over 5 x to the negative 1 over 5 power. Alright, so what exactly is going on, huh? Well, let's just go ahead and put this down to the bottom first and then see what exactly we need. So right here, perhaps we can multiply this out, right? So this is 2x minus 8, and then we have the x to the 4 over 5. So that's that. And then I'm just going to write it as 4 and that, so it's 4 parentheses x minus 4 square. I'm thinking if I want to factor out the x minus 4, I think that's factor out the x minus 4. Okay, let me show you. Hold on, sorry. Alright, so number 50. Notice that we have the x minus 4 here to the first power, and likewise x minus 4 to the second power. We can factor it out, so let's go and do that first. So this and that factor out an x minus 4. And then what we're going to get is 2 times that, so 2x to the 4 over 5 plus, now this right here originally has 2 power. Right now we took out one of them, so we have one more. So this right here is 4 and that, so 4 and then one more power. This is on the bottom, which is the 5, and then negative 1 over 5th power, well, goes down here, so x to the 1 over 5 power. So yeah, that's what we have. And now I'm just going to multiply this by 5 and also x to the 1 over 5 power. So multiply this by 5. So it's meant to be like 5 right here and then x to the 1 over 5. Yeah, and then the plus. Okay, because this and that can be combined at 5 times 2. Okay, so x minus 4 times, the denominator here is 5x to the 1 over 5 power, and this is 10. X to the 4 over 5 times x to the 1 over 5 is just x to the 5 over 5, which is just x, so it's 10x. And then this guy, just distribute it, so we have plus 4x minus 16. Yeah, that's about all. So here I'm going to leave it as x minus 4, and then combine this and that, which is 14 x and then minus 16 over 5x to the 1 over 5. And I factor things out. I did. For my answer key, right here I factor out 2, because if I factor this, then minus 2, I factor out everything, right? So I factor the out 2, and then x minus 4, and that becomes 7x minus 8 all over that denominator, 5x to the 1 over 5. Yes, 50 questions. Wow. This sheet done. Take a look. Next one, log and exponential. Not so bad, I would say. All right, so exp and log, right? Logarithm and also exponential. Then is in particular e to the whatever power. So number 51. We're just going to multiply things out, and the expression is this: 2 times e to the x minus e to the negative x over 2 times e to the x plus e to the negative x over 2. First, this and that cancel. Good. And then we see that we have the 1/2, right? So we can just keep it at the front like this. And now the beauty is that you see this is minus, and this is plus. So it's kind of like the conjugate multiplication, huh? So we just have to square the first one. And now e to the x, if we square that, we just need to multiply the powers. So this becomes e to the 2x. Okay? So we will get e to the 2x. And then minus, square that, again you multiply negative x with 2. So it's e to the negative 2x. So it's like this. And then with all that, we are done. Okay? And here is a small preview to your calculus class. Because in fact, this expression, they actually represent some new functions. This one right here, e to the x minus e to the negative x over 2, it's actually the so-called hyperbolic sine function of x. And when we have the plus in between, this right here is called the, you guessed it, hyperbolic cosine of x. And you can call this sinh, and you can call this cos. Yeah, and notice that if you have 2 times sinh and cos, we end up with this. So what's this answer? We have 1/2. Well, 1/2 is like this over 2, right? But you see the input here, we have 2x, and then this is negative 2x. Yeah, so what do you think what this is? This is exactly sinh of 2x with a 1/2. Yeah, because you can put that over 2 like that. So yes, 2 times sinh times cos gives you sinh of 2x. This is very similar to what? Your good old trick identity, right? Sine of 2 theta equals 2 sine theta cosine theta. Right now we are saying we have the sinh of 2x equals 2 sinh of x cos of x. Yeah, and to prove this identity, we just change them to the exponential version of them, and then just multiply out, and then we got it. Yeah, so just like that. I'm sorry, I'm a little bit tired. But this is actually pretty cool stuff, so I just want to give you guys a quick preview. I will also like to try to finish the problems before I had to charge the phone. I don't know if my iPhone can go. It was 100%. I don't know if it can go all the way. We will see. Number 52. Right? Number 52. Here we have e to the x minus e to the negative x over 2 square, and then minus e to the x. Sorry, this right here should be a plus. And then minus e to the negative x over 2, and then square. Right? So the question that's asking is this right here, which is cos. And the input here, you see the x and negative x, right? So the input here is x. And then we see that we have this quantity square, so we have the square, and we can put a 2 right here. And then minus, the other one is sinh. So we have the, let's put it on this, it's cooler this way, 2, and then minus, this inside is sinh of x square. So we're trying to see what this will give us. Well, all this right here, you don't have to know this in order to solve that, because we just have to multiply it out and then simplify. Okay, first thing first. 2 square on the bottom, let's leave it 4. And then on the top, where we see that we have a plus b squared. So just multiply out the binomial, right? So we take the first thing, square that, so we get e to the 2x. Right, square that, just multiply the powers. We add 2 times this and that, so 2 times e to the x and e to the negative x. Lastly, we add this thing square, which is e to the negative 2x. Then minus, same thing, right here we have a 4, and then this is a minus, so you just change this to minus, so then the rest is the same. So we have e to the 2x minus 2 times e to the x times e to the negative x, and then plus e to the negative 2x. Yeah. By the way, do you guys notice that what this is? E to the x times e to the negative x. We add the exponent, it's just e to the 0, which is just 1. So in fact, this right here is just equal to 2. And this right here is equal to negative 2, right? So yeah. Okay, and then right here we have minus, so I'm going to put them together and then just distribute the negative. So together we have a 4, and then this is e to the 2x plus 2, and then plus e to the negative 2x. Distribute the negative, so we have negative e to the 2x, and then this is a minus, right? But negative times a negative gives us a plus, and then we still have that 2. And lastly, minus that, which is e to the negative 2x. Okay, and now what do we see? E to the 2x cancel, e to the negative 2x cancel with that. On the top we have 2 plus 2, which is 4 over 4, so the answer is 1. So this right here, cos square x minus sin square x, is actually just equal to 1. This is one of the hyperbolic identity. Okay, it's very similar to cosine square plus sine square is equal to 1, but this is a minus version. Yeah, and the reason for this is because this right here comes from hyperbola instead of a circle, that's why. But again, it's just some preview. Alright, number 53. E to the 2 ln x minus e to the negative 2 ln x all over 2. So this right here, well, the input is what? 2 ln x, and then it was a minus. So this question right here is asking hyperbolic sine of 2 ln x, right? But anyway, again, you don't have to know this to simplify that. Okay, e and ln, they can almost cancel it because here we have 2 spotting us. But what do we do? Thanks to a log property, when we have 2 times ln x, we can put a 2 right here, make that into an exponent. Likewise, we'll put the negative 2 right here into the exponent. So we are going to get e to the ln of x squared, and then minus e to the ln of x to the negative 2 all over 2. And now we can cancel the e and also the ln, and then e and also the ln. Okay, so this right here, let's just put on the 1/2 like this right here, and this is just x squared minus x to the negative 2. But x to the negative 2 is the same as 1 over x squared. And now what? We can combine them. We can multiply this by x squared and x squared. So altogether, we have 2, and then x squared on the bottom. And then this and that is x to the 4th power, and then minus 1. Yeah, so this right here, since of 2 ln x, it actually is x to the 4th power minus 1 over 2x to the 2nd power. So yeah. Okay, and then that's about it. So keep in mind though, right here notice that e to the ln's power, they cancel because they are the inverse functions of each other. And for the next 3 questions, we are going to practice how to write some expressions with base e. So I'll just write this down. So the next 3 questions, write the following with e for the base, okay, with base e. So the first one, which is number 54, I'm talking about x to the x power. It's pretty strange, huh? It's like the first time we see this. We have a variable for the base and then a power for the power. A variable for the base and also a variable for the power. We don't like that. We like to have base being e, right? E for the base for exponential function is the best. And this is like a combination of like, let's just do it. Anyway, so we see that we have x here. That's not what we want. We want to have base e. So what can we do? That's what we did earlier. We are going to first write this as e, but then remember e and ln x cancel. Right? So we can write x as e to the ln x and then raised to the x power. But now we have e to this power and then to that power. So what can we do with the powers? Multiply them. So this right here is just e to the x times ln x power. Pretty crazy stuff, huh? So it's kind of like what we did earlier, right? Just how to think backwards. Okay, let's try another one. Number 55. Square root of x raised to the x squared power. Yeah, crazy, huh? But don't worry. What's square root of x? Let's write it down like that first. So this right here, we can put it as e to the ln of square root of x. And then raised to the x squared power. Yeah? Whatever this is, you just put it inside the ln because e and ln will cancel. And then we can of course multiply the powers. So this is e, and then we have the x squared ln of square root of x, like this. But in fact here, we can actually continue a little bit more because when we have the square root, it's actually the same as 1/2 power. So in fact, I'm going to rewrite this as e, and then we have x squared, and then we have ln of x to the 1/2 power, like that. Why? Yes, we can put the 1/2 to the front, right? Thanks to the log property. So finally, I'm just going to present the answer for you guys as e and then 1/2, and then we have the x squared, and then ln x. Yep, just like that. Super, super cool. Okay, and then we have one more. Number 56. I have x for the base, and then the power is x over ln x power. You're not going to believe like how this simplifies to. Ready? Let's go. X, again, let's do that, right? So x is just e to the ln x power. But this time we raise that to the x over ln x power. What do these two powers do? We multiply. Ln x and this cancel. So in fact, this right here is nicely equal to e to the x power. Yeah. So this can be like a very scary expression, but it's really just nicely equal to e to the x. Yeah. So just quick examples, like how you write like a crazy function. Like you have some power, but if the base is not e, then you do this kind of things to make it base e. Alright, now for the rest of this category, we'll just practice some more logarithm properties. So number 57, notice that we have ln of e to the x plus x e to the x. So what can we do in this case? If we look at inside, both of them have e to the x. We can factor it out. So in fact, this right here becomes ln of e to the x, right? And then the leftovers are 1 plus x. And the inside here is now a product of two things. Ln of a product is a sum of the ln's. So we can write this as ln of the first thing, which is e to the x, and then we add ln of the second thing. And what's the first one? Yeah, ln and e cancel out like that as well because they are inverse of each other. So finally we get x plus ln of 1 plus x. So that will be the simplification for this one. Okay, I'm going to fill in number 58 here. Number 58, we have a big expression, ln of x to the 4th power, and we have the square root, x squared plus 1 over x plus 5. So, similar to earlier, when we see product, we are going to break it apart as a sum. When we see a quotient, we are going to break it apart as a difference. And we're going to do both of them at the same time. Ready? First one, we will have ln of this thing, which is x to the 4th power. It was a product, so we add ln of this. I'm going to write the square root as a 1/2 power, just like what we did earlier, huh? So I'm going to put down x squared plus 1, and then to the 1/2 power. And then this right here is on the bottom, so it's a difference. So it's minus ln of x plus 5. Now, we can put the power to the front, the power to the front, and then be really careful. When you have a sum inside of a natural log, we cannot break them apart. Earlier, we were able to factor out the e to the x. So it was a product, so we can break them apart. If it's a sum, like ln of 1 plus x, we couldn't do a thing, so we leave it. So this one we will have to leave it too. And likewise, later on, you will see we just have to 1/2 at the front. That's the most we can do. Anyway though, this right here is the 4, and then ln x, and then 1/2 at the front, ln x squared plus 1, and then lastly minus ln of x plus 5. Okay, and there's one little issue I want to address for this right here. If you take a look right here, originally, can x be -1? Yes, because -1 put inside here, then that will be positive, that will be positive, -1 plus 5, it's also okay. But if you look at this, can x be -1? No, because we have ln of -1. We cannot have negative number inside that ln, right? So, something's wrong. Here's the deal. We have an even power here. When we bring that to the front, right here, to maintain the same domain, we will have to attach an absolute value. So, that's a little thing. Alright. Done. Okay, number 59. Log base 4, 8 over the 4th root of x to the 3rd power plus 2x plus 5. Alright, so you see how earlier we took 2 steps, but if you want, can you go from here to here? Sure, just be really careful, right? Because you know you can break it apart and then bring the power to the front, right? Do 2 things at a time. Let's go ahead and do that right here. Firstly, I'm going to have log base 4 of 8, and then minus log base 4 of whatever this is. But we know this right here is the 1 over 4 power. The 1 over 4 can be brought into the front. And then we just have the inside x to the 3rd power plus 2x plus 5. And now, what exactly is log base 4 of 8? I'll show you guys a quick way to do this. That's why I came up with this question for you guys. The little formula that you can remember is when you have log, whatever base right here, if you can match b to some n, and then if this right here is b to some m, okay, this right here is just equal to m over n.
That's it. So if you look at 8, this right here, it's nicely equal to 2 to the third power. And if you look at 4, this right here is 2 to the second power. So it's just 3 over 2, right? So if you remember this, you can compute this in a very quick way. Right, I have another video on this right here, so I will just link to you guys like the explanation. But yeah, that's all you have to remember for this. And then we cannot break it apart, so we'll just leave it. Right, this is the best way to compute logarithm without using a calculator. So thanks to the base and all that stuff. Alright, number 60, I'm going to put it down right here. ln of the cube root of e to the x over x squared plus 1. Ready? ln of this guy. But this is e to the x and then to the 1/3 power. ln and e cancel. So we have what? 1 over 3x. Yes. So we actually just have 1 over 3. Just think about 1 over 3 brought it to the front, and then ln and e cancel, and we have the x. Okay? And then minus ln of that, which is x squared plus 1. Okay? So again, look at e to the x and then to the 1/3 power. 1/3 to the front, so no more. And ln and e cancel, we have the x. And then ln of the denominator, just like that. Yeah, that's it. Okay. Oh, 20% left. I will have to charge it soon. All right, number 61. Number 61, we are going to write everything in terms of x to some power p. So I will just write this down. Write the following in terms of x to some power. So if we have 1 over x to the second power, then we'll purposely write it as x to the -2. I know this is unusual, right? Because usually we want to have this rather than that. But let me tell you, in calculus, if you want to use the so-called power rule, then we must have this form. So that's why. So let's see. Number 61. Firstly, we have square root of x times 2 plus 4x squared. Firstly, square root is the same as 1/2 power, so we can look at this as x to the 1/2 power times 2 plus 4x squared, and then just distribute. So we get 2x to the 1/2 power, yeah, and then take this times that, so we have plus 4x, 2 plus 1/2, right? 2 plus 1/2, and then just get the common denominator, all that stuff. So that's 4 plus 1 is 5. So I'll just put this down, 5 and then over 2. Okay, so just add the exponents, and that's it. That will do it. That will do it. Okay, next one, number 62. We have 4 plus the cube root of x, and then we square that. Well, for this one, I'm going to first write it as 4 plus x to the 1/3 power, but then we will have to square that. And that's use the binomial formula, right? So I'm going to square this, which is going to give us 16. Next, we are going to add 2 times this and that, which is going to give us 8. And then keep this x to the 1/3 power. And lastly, we add this square. When we square this, we just multiply the exponent by 2. So we have plus x to the 2 over 3 power, just like that. And then we're done. and then we can be happy and use the power rule, power rule, power rule. Okay, 63. Okay, this right here is a little bit bigger multiplication. We have x squared times x to the 4th power plus 6, and then square. Word to file operation, do the exponent, this one right here first. So here we have x squared, and then binomial again, right? So we have to square that. So multiply the power by 2, so we have x to the 8 plus 2 times this and that, which is 12x to the 4, and then 6 squared, which is 36. Yeah. And then finally just distribute the x squared, so we have x to the 10 plus 12x to the 6, and then plus 36x squared. Done. Yeah. All right, number 64. We have 2 cube root of x times 5 square root of x, and then plus the cube root of x squared. So the first thing is, let's just change all the radical into fractional exponents. So this right here is 2x to the 1/3 power times 5. This is x to the 1/2 power. And then this is the same as x to the 2/3 power. Okay? And then let's just multiply this in. So 2 times 5 is 10. X, we will have to add the power. So just go ahead and do 1/3 plus 1/2. And I'll show you guys the TikTok way to do this. This times this is 2. This times this is 3. You add them and you multiply them. So you get 5/6. Don't be too impressed. This is just adding fractions. Okay. And then next one, we add 2 times that is just 2. And then 1/3 plus 2/3 is just 3/3, which is just x to the 1st power. So this is it. Okay, this is it. So also let me take a look at my answer key to see if I have my answer key being correct. Alright, very nice. All right, next one, we have 65. We have 1/x squared plus 5/x, and then 8x squared minus 3x. Well, we are going to take care of this 2 power first. This right here becomes, I can write it as x to the -2. And then 5/x, we can write that as plus 5 x to the -1. And then this right here, let's just keep them as how they are. All right, now we're just going to follow this out, right? So we take this times that, and remember we will have to add the exponent. -2 plus 2 is 0, so the first one does not have x anymore, but we have the 8. Next, we take this times that. -2 plus 1, so it's x to the -1 power. So that will be -3x to the -1. Next, we take this times that. That's plus 40, and then -1 plus 2 is x to the 1st. Yeah, and lastly, this times that is minus 15 and no x, right? -1 plus 1 is 0. Yeah, and then lastly, we just look at the 8 and also the minus 15. That should be minus 7. So -3x, -1 plus 40x, and then minus 7. That's what I have. Yeah, this is definitely okay. The order of this right here doesn't really quite matter. Alright, number 66. Now we get to the fraction part. Here we have x squared plus 9 over over 18x to the 4th power. All right. So you have two ways to look at this. You can bring the x to the fourth power up and look at that as x to the -4 and then multiplying. That's fine. Or you can just split the fraction and then subtract the exponents. I will do the second way. This right here, I'll write it as x squared over 18x to the fourth power. And we can do this because the denominator is just one term. 18 times x to the fourth power is just one term. And then we add 9 over 18x to the fourth power. Now simplify. 2 minus 4 is -2, and that's a new power, right? So right here I can write this as 1 over 18 x to the -2 power. And then right here, 1 over 2, right? So let's reduce that the regular way. And then 1 over x to the fourth power, x to the -4. Done. Just like that. 67. 5x squared minus x plus 8 over x square root of x. Okay, so I'm going to split the fraction that what we did over there. So first we have 5x squared over, this is x to the first times x to the 1/2, which is x to the 3 over 2 power. 1 plus 1/2, 3 over 2. And then do the same right here. In fact, I'm not going to write it. I'm just going to write it as x over x. And then this is square root of x, so x to the 1/2. Okay. I didn't combine it because I have x over that, so I can cancel them. And finally, for this one, plus 8 over x to the 3/2. Perhaps I'll make the 1/2 real too. Okay. Anyway, 5 is 5. 2 minus 3/2 is positive 1/2. So 5x to the 1/2. Next, this and that cancel. We have 1/2 on the bottom, so that's the same as minus x to the -1/2. Lastly, just 8 over that, so we can say this is 8x to the -3/2. Just like that. Okay, I'm gonna do 3 more and then I'll take a drink. I'll take a sip of my drink over there. Number 68. Okay. 2x to the third power plus 1 square over 4x squared. Okay. Open the top. So square the first one. So 2 squared is 4. X to the third power squared, you multiply the power by 2, so it's x to the 6. We add 2 times this and that, which is 4x to the third power. And lastly, 1 squared just plus 1. So that's the expansion for the top. And now for the bottom, we'll just go ahead, divide this by 4x squared, divide this by 4x squared, and divide this by 4x squared. So 4 and 4 cancel. The first one is x to the fourth power. Next one, 4 and 4 also cancel, so we just have plus x. And lastly, plus 1 over 4, and then we can write the x as x to the -2. So this right here will be the simplified answer. Yeah. All right, number 69. We have negative x to the fourth power plus 7 square root of x over the cube root of x squared. All right. This is negative x to the fourth power over. Let's write this as x to the 2 over 3 power plus 7x to the 1/2 power over, this is x to the 2 over 3 power. Alright, now the rest is just subtract the exponents. This is minus, we have x. 4 minus 2/3. So that's 12 minus 2 is 10. So this is 10 over 3. Next, we add 7. Okay, 1/2 minus 2/3. So we need to multiply this by 3, 3, 2, and 2. So 3 minus 4 is -1. So it's -1 over 6. So let me just double check my answer key. Yeah, so negative x to the 3 over 10 plus 7x to the -1 over 6 power. Yeah, and let me just check. Maybe I need to. Yep, I need to charge my phone now. Okay. Let me also get a new marker. No, I want to get a fresh one. Yeah, so how to do that? Sometimes you don't remember what you're supposed to do, or like you just don't even know what you're doing. Anyway, number 69, yeah? Okay. Now, number 70. Here we have parentheses 4 minus 3 square root of x squared over x squared. All right, so let's go ahead and do the following. So expand the top, right? So against binomial, so square the first one is 16 minus 2 times 4 is 8 times 3 is 24. And then we have this term as well, which is x to the 1/2 power. And then lastly, we add this term square. So 3 squared is 9, square root square is just x, yeah? And then over x squared, so it's over x squared here, over x squared here, and also over x squared here. So the first one, we can write this as 16x to the -2. Next one, minus 24, 1/2 minus 2. Minus 4 over 4 pretty much, so it's x to the -3 over 4, and this is 1 minus 2, just -1, so it's plus 9x to the -1. Just like that. Done. Yay, we write in terms of x. Cool, another sheet done. Okay, so another crazy one now. Okay, 30 more to go. I do not have question 101 this time. Because I have a perfect 10 exactly category, so I don't know what question 101 should be. I don't know. Maybe I'll come with something, or maybe not. I have no idea. Okay, you are going to see this kind of expressions from the quotient rule. So we're just going to do it, simplify, hope for the best. Okay, number 71. We have 3 minus 4 times 2 minus 1 plus 2x times -4 over 3 minus 4x squared, right? So yeah, this is actually from the so-called the quotient rule when we do the derivative. So we see this kind of crazy expression. What we do is, just like what we did before, look at the top, simplify it, and then try to see if we can cancel anything at the end or not. So let's see, take the 2, distribute backwards, right? So we are going to get 6 minus 8x. That's the best we can do. Now, negative and then negative. So make sure you distribute it, and then also make sure you distribute it. So it's positive 4, just think about it, positive 4 times this, which is plus 4, positive 4 times that, which is plus 8x, over the denominator, which is 3 minus 4x squared. 8x minus x, bye-bye, and then together 6 and 4 is 10 over this guy, which is 3 minus 4x, and then square, and then we are done. Cool, huh? Now, the next one, I'm going to just come here and write it. So number 72, we have 1 over 1 plus parentheses x plus 1, so x minus 1 over x plus 1 square times this right here. We have x plus 1 square, and then x plus 1 times 1 minus x minus 1 times 1. Crazy stuff, but don't worry, I got you. Firstly, we have this fraction times the other, so technically there's an invisible parentheses on the bottom. And then notice this right here, right, x minus 1 over x plus 1 squared. We can look at the top being squared and also the bottom being squared. And we are lucky because this right here is x plus 1 squared. What we can do is just go ahead and take this, distribute it. Right? Take the whole thing, distribute it. Because that way, what we are going to get is this times that, which is just x plus 1 squared. And when we take this times that, the denominator and that will cancel, so we just have plus x minus 1 squared. Okay? On the top, let's see, this is just x plus 1, and then minus x, and then plus 1. So, of course, this and that just cancel, so 1 plus 1 is 2, times 1 is 2. Yeah? And then right here, let's multiply this out. We get x squared plus 2 times this and that, which is 2x, and then plus 1 squared. And then for this version is x squared minus 2x, and then plus 1. We are adding this and that together, but we see that 2x and negative 2x, they will be gone. Finally, we have 2 on the top over this and that, which is 2x squared, and then 2. So we can factor out the 2, and then x squared plus 1, and then reduce. So finally, we get 1 over x squared plus 1. Done. Okay? So some of these kind of questions, they can actually simplify really, really well. Okay, number 73, we have the following. So we have x to the third power plus 1 square times 3x squared, and then minus x to the third power times 2 times x to the third power plus 1, and then times 3x squared. Everybody over x to the third power plus 1, and then to the fourth power. Okay, number 73. Before we multiply out anything, notice that here we have x to the third power plus 1, and this right here has a second power, so this is one term, right, because it's separated by this subtraction, and this is another because they're just multiplying it. So we can actually factor that out. So let's see, this right here, if we factor it out, we will get x to the third power plus 1 all the way at the front, and then this is going to be, okay, we can write this down first, so 3x squared times one more of this, right, so it's just x to the third power plus 1 minus, oh, put this down, minus 3 times 2 is 6, and then x squared times that is x to the fifth power. Yes, and over this denominator, which is x to the third power plus 1 to the fourth power. Okay, one thing, we can cancel this out with one of them, right? So the power becomes 3. Now we just have to work this out. If we multiply this out, we get 3x to the fifth power, and then plus 3x squared, and this and that can be combined, so we will. So finally 3 minus 6, which is negative 3x to the fifth power plus 3x squared all over that, which is x to the third power plus 1 and then to the third power. Done. Yeah, and then here's the trouble again. I will have to erase the board like every single time because the question is so big, and then yeah, it will take the whole board to fit in the question. Okay, just want to make sure that my phone is still working. Number 74. 1 plus x squared times 1 over 2x, 1 over 2 square root of x, and then minus 2x square root of x over 1 plus x squared squared. Okay, so how can we simplify this? Well, we have a complex fraction, so we have to remember what we did before, right? If we have a complex fraction, we're just going to multiply the top and bottom by the common denominator, the small one. So just this. So let's go ahead and multiply the bottom and the top by 2 square root of x. Okay, let's see what we get. Take this times the first term. They cancel, so we just have 1 plus x squared, nothing else. Next, we take this times that, minus 2 times 2 is 4, square root of x times square root of x, this is just x, times one more, so it's x squared, yeah? It's x, one more, so x squared. And then on the bottom, we'll just keep it as that, so that is 2 square root of x times 1 plus x squared, and then square. And of course, right here we can combine it like terms, so this is 1 minus 3x squared over 2 square root of x times 1 plus x squared and then square. Yay, done. Let me fit in number 75 here, should be okay. Okay, here we have similar question, x minus 3 times 1 over 3 cube root, oh my goodness, cube root of x squared, yeah, and then minus the cube root of x over x minus 3 squared. Alright, so very similar. Let's just go ahead and get to work. Multiply the top and bottom by this. So 3 cube root of x squared, so 3 cube root of x squared. Okay, take that times that, they cancel, so we just have x minus 3 first, then minus, alright, this is just a regular 3, but cube root of x times cube root of x squared is just x, yeah? Because you add the powers inside, just third power, x to a third power inside of the cube root, so just x. Okay, and then on the bottom, we'll just leave it. So 3 cube root of x squared times x minus 3 squared. And then of course, this and that, cancel them out. And because x comes first here, so I will also write that down first. So negative 2x minus 3 over 3 cube root of x squared times x minus 3, and then square. Just like that. Okay, we have square root of 1 minus, so square root of 1 plus x squared. Square root of 1 plus x squared minus x times 1 over 2 square root of 1 plus x squared times 2x. Yeah, and then over square root of 1 plus x squared, but then we square that. So that's the write out. Okay, let's see what's going on. Firstly, you should notice this right away. Square and also the square root cancel out. Yeah, and then again we have, okay, 2 and 2 cancel out. That's good. But we have this little denominator. So let's multiply the top and bottom by square root of 1 plus x squared plus x squared. Okay, so what exactly do we have? This times that is just 1 plus x squared, right? No more square root. This times that, they cancel. But we have a minus. X times x is x squared. Right? Good. And then here, earlier they canceled it already, so we have parentheses 1 plus x to the second power, and then we have the square root. So square root of 1 plus x squared. On the top, this and that cancel out. So it looks like we just have 1 over that, right? But notice the inside, this is 1 plus x squared, and this is also 1 plus x squared. So in fact, we can combine the powers. This right here is the same as 1/2 power. So let's go ahead and write it down like this. This is, okay, let's do this in our head. This is the same as 1/2 power. This is the first power. So 1 plus 1/2 is 3/2. So we can write this as parentheses to the 3/2 power with 1 plus x squared inside. Yeah? Okay, 1/2 power and the first power. Add the powers, we get 3/2, and we can just leave it like that. And if you want to rewrite this in different ways, you can also write this as 1 over the half power becomes a square root. And then the third power, you can put the third power on the outside or inside. Usually inside might look better. So we just put it 1 plus x squared and then third power. So this or that. Okay. Or better yet, you can also look at 2 plus 1 is 3, and then the square root is the half power. So yeah. Yeah. Okay. Okay. Number 77 to 80, the question gets even bigger and bigger. So I will have to erase this again. All right, number 77, we have x plus e to the x times e to the x, and then minus 1 plus e to the x times 1 plus e to the x. And then all divided by x plus e to the x and then square. Okay, let's just go ahead and get to work. So take this, distribute it backwards, right? So we get x e to the x, and then e to the x times e to the x, we just add the powers together. X plus x is just 2x. So together we get plus e to the 2x. Done for that part. And then we are going to subtract. Now, this is just 1 plus e to the x squared, right? So we can just go ahead and binomial expansion that. So just 1 and then plus 2e to the x and then plus e to the 2x. Okay? And that's about all. Now over x plus e to the x and then square. And notice that right here we can just, okay, so this is minus 1 minus 2e to the x and then minus e to the 2x. We can cancel out e to the 2x with that. That's the most we can do. So here we have x e to the x minus 1 minus 2e to the x, everybody over x plus e to the x and then square. Just like that. Okay. Because earlier the phone was at 10%, right? I want to make sure that the charge actually works, and then of course I wouldn't want to stop the video. So, and then if I have a microphone attached to the iPhone, I have to buy a different connector. So that connector I don't think is the best. Yeah, a connector with the charger and also the microphone. Yeah. Anyway, let's just get to work. 79. No, I didn't do 78. 78. Ready? I am. Okay. X squared plus e to the x times x squared e to the x plus 2x e to the x minus x squared e to the x times 2x e to the x, no, 2x plus e to the x, all over x squared plus e to the x and square. Wow. When I was typing out these questions, they didn't look that long, but once I have to write them down on the board, it's like, oh my goodness. But it's okay, we can do it. Here we go. This is the binomial times the binomial, right? So let's go ahead, multiply. And technically, I should not say binomial. Binomial, loosely speaking, well, technically speaking, is a polynomial, has two terms. But this is not polynomial when we have e to the x. So anyway, I'll just say 2 terms times 2 terms, so we'll just forward. Alright, so take this times that, we get x to the 4th power, e to the x. Next, this times that, we get plus 2x to the 3rd power, and then e to the x. Yeah, and then take this times that, e to the x times that, you add the powers, yeah? And then the x squared, just leave it. So e to the 2x here, and lastly, this times that, so we have plus 2x e to the 2x. Okay, and then we'll take this distribute, so we get minus 2x to the 3rd power, and then e to the x, and then minus x squared e to the 2x, all over x squared plus e to the x, and then square. Okay, let's see. Now, 2x to the 3rd power e to the x, this and that cancel. x squared e to the 2x, they also cancel. Yeah, that's about all. And we have this and that. Can we factor stuff up? Yeah, but it does not really do us any good, so we can just leave it. So the final result, we can write it as x to the 4th power e to the x, and then plus 2x e to the 2x, everybody over this guy, which is x squared plus e to the x, and then square. Done. Alright, number 79. 4x minus 1 squared minus x plus 2 times 4x minus 1, and then times 4 all over 4x minus 1 to the 4th power. Technically it should be square. Comment down below if you know what I mean by that. But anyway though, if you can tell me like where did this question come from, that would be pretty cool too. But anyway, so how do we simplify it? Notice how here we have 4x minus 1 squared, and here we have 4x minus 1. So take advantage of that. Let's factor it out first. So here we have 4x minus 1. Okay, and this one here will be 4x minus 1 left. And then what do we have left then? This is 8. So I'm going to actually use blue. This is 8. Right. So perhaps I will just leave it like this. So we have the minus. Let's keep it like this, minus 8 and then x plus 2. Yeah. Okay. Over, this is 4x minus 1 to the 4th power. Then we can cancel, right, one of them out. That's good. And now we can just fix the inside. So this is negative 8x minus 16. Yeah, and then just combine it, that's all. So finally, 4x minus 8x is negative 4x. Can I think I'm just going to write down the answer right here so I can use the button to do the next one. So this right here equals, this and that is negative 4x and then minus 16. Can you find out the negative 4? Yeah, but doesn't really matter. No, it's not. No. Negative 1 minus 16, so it's minus 17. And then that for the answer, 4x minus 1 to the 3rd power. Done. Yeah. 80. You'll see this one. Okay, ready? X squared minus 4x plus 3 times 3x squared plus 3 minus x 3rd power plus 3x times 2x minus 4. Everybody over x squared minus 4x plus 3 squared. Oh my god. Can we factor out anything though? Yeah, we cannot factor out anything. So we just have to deal with it. Multiply it out and combine terms and then hope for the best. Yeah. So here we go. this times that, we get 3x to the fourth power. This times that, we get plus 3x squared. Next, move to this times that, which is negative 12x to the third power. And then this times that is negative 12x. And then this times that is plus 9x squared. And then this times that is plus 9. Okay. And for this one, I'm just going to multiply out right here first and then distribute the negative. So if you look at this times that is 2x to the fourth power. And then this times that is negative 4x to the third power. And then this times that is plus 6x squared. This times that is minus 12x. And then I'm going to distribute the negative. So I will get negative 2x to the fourth power plus, oh, I like to do this. Let me show you. Negative times negative. Anyway, and then 4x to the third power, and then becomes negative 6x squared, and then negative times negative, and then we have the 12x squared, 12x. Wow, all over this guy, x squared minus 4x plus 3 and then square. All right, let's see what we can do with it. So let's look at all the x to the fourth power term. We have 3x to the fourth power and then minus 2x to the fourth power. So that's just 1x to the fourth power. So x to the fourth power. All right. Next, let's look for the x to the third power term. Here we have minus 12x to the third power plus 4x to the third power, so that's minus 8. Minus 8 x to the third power. Right? And then next one, x squared terms. Let's see. Oh, just blue. 3x to the second power plus 9. X to the second power is 12. 12 minus 6 is positive 6. So this right here plus 6x squared. Alright. And then, oh, we can have something cancel. This is negative 12x, positive 12x. And this something get cancelled there. And then this is plus 9. So just put a plus 9. Okay, so that's pretty much a simplification for the numerator. Can we possibly factor this? I have no idea. Let's not even bother with it. Let's just look at this and then over x squared minus 4x plus 3 squared and then call it for the day for that question. Okay? Alright, so let me just take a look. Yay. I hope the audio is okay. But anyway, this is number 80. Yeah. Wait, how many hours has this been? It's only 3 hours and 4. Okay. It's not so bad, but like, it's very late. Anyway. Okay, next, we're going to solve equations, right? But this one is like solving for dy dx. It's like, let me just write down. So I want to tell you guys that this right here that we're using, this is actually like a variable itself, okay? You can look at this as like capital D, right? For like derivative, that kind of thing. Do not cancel the d and d, right? dy dx. Do not cancel this out and out. Don't do that. The whole thing right there is a notation itself, okay? And the goal is to isolate that. And let's see, number 81. So firstly, we have this, we have 2x minus 4x, and then dy dx. Minus 4y plus 4y plus 2y, and and then dy dx equals 0. So this is the so-called implicit differentiation. And again, I am using the dy dx notation. This is the whole thing, and our goal is to just isolate that. For this kind of questions, you will see that the expression is like very, very scary. And if you just keep track of everything, it's not so bad. Let me show you guys how I like to do it. Firstly, let's just look at the terms that has dy dx and then keep it on one side. So I will keep them on the left hand side because they have dy dx. And I'm going to factor it. I'm going to just put down a parentheses, and I'm going to put down a dy dx at the end of the parentheses. So you see this right here will be the negative 4x. I'll leave it like this, and then plus 2y, just like that. And then we will have the dy dx at the end. And the reason that I do have the dy dx at the end is because if you put that at the front, it might look like a different notation, because this means the so-called you take the derivative, and this is the derivative, meaning the result already. They are very different things. So that's just that. But for now, again, just treat this as a variable, and let's focus on how to isolate that. So we took this and that out, and then we have the dy dx at the end, and we are going to move this and that to the other side. So move this to the other side, we get positive 4y, and then move this to the other side, we get minus 2x. Yeah. And then you see that we can now just divide this on both sides, right? So that's pretty much it. Dy dx equals 4y minus 2x over, let me write down the 2y first, and then minus 4x. Yeah. Can we reduce? Yes. We can factor out 2, and that will give us 2y minus x. And then right here we can factor out 2, and that's y minus 2x. And this 2 and that 2 cancel, so we just have 2y minus x over y minus 2x. Done. Right? So you will see this is actually really not so bad. It takes about like 2 lines usually, depending if you have like big fractions or not. Right, number 82. Alright, it takes like, I'm just going to write it down, I'm not going to talk too much. 4x to the third power plus 2x squared y dy dx plus 2x y squared plus 3x, plus 3y squared dy dx, and that's equal to 0. Alright, so once you have this expression, again, do what we did earlier. This term and that term, they have the dy dx, right? So let's just go ahead, we write down 2x squared y plus 3y squared, and then we have the dy dx. And then let's see, we will move this and that to the other side, so perhaps let's put this first, right? So negative 4x to the third power, and then minus 2xy squared, and at the end just divide this on both sides. That's it. Yeah. So dy dx equals negative 4x third power minus 2xy squared over 2x squared y plus 3y squared. Yeah, just like that. Yeah, and I would like to tell you, for doing this kind of things, the hard part is come up with this expression when you are actually doing the calculus. Yeah. Alright, next one, a little bit more challenging. Challenging enough that I think I should erase the board. Right, number 83. We have dy dx here, and that's equal to 3 times 1 plus x plus y squared, and then square, and then times 1 plus 2y dy dx. Yeah. So here's the thing. You see, we have this thing times that. Here we have the dy dx. What we will have to do first is take this whole thing, distribute it, right? So let's do that. So here we will get dy dx equals, so this whole thing multiplied by 1, just leave it. 3 times 1 plus x plus y squared, square, done. Plus 3 times 2, so we have 6, and then the y, and then dy dx. No, sorry, and all that thing. 1 plus x plus y squared, square, and then dy dx. Okay? Now, we have dy dx here and then dy dx over there. And this is technically like a 1 dy dx. We will move this to the other side, and that will be negative. And then we'll factor out the dy dx. So it will look like 1 right here, and then minus this term, which is 6y, and then 1 plus x plus y squared, square, and then factor out the dy dx at the end. And that's equal to that guy, which is 3 times 1 plus x plus y squared, and then square. And then finally, we can just divide this on both sides, that's all. So dy dx equals 3 times 1 plus x plus y squared, and then square, all over 1 minus 6y times 1 plus x plus y squared, and then square. Should we expand this? No, don't do that. Don't. It's not healthy. Don't. Just leave it like that. Just leave it like that. Like, please. Don't. I'm going to erase this right away. Right, number 84. 3 times the parentheses, x plus y squared, and then we have 1 plus dy dx, and that's equal to 2x plus 4 dy dx. Yeah. So how do we do it? This dy dx, yeah, so inside of this parentheses, and we have this in front. So we'll take this thing, distribute, yeah. So we get 3 times x plus y squared times 1, just this, plus 3 times x plus y squared dy dx. And then that's equal to 2x plus 4 dy dx. Now, I'm just going to move this to the other side, factor out the dy dx. So we have this, which is 3 times x plus y squared, and then minus the 4, and then they have the dy dx term. That's equal to. The 2x is still here, but we will move this to here because it didn't have the dy dx. So minus 3 times x plus y squared. And then finally, just divide this on both sides. So we have dy dx equals 2x minus 3 times x plus y squared over, that is 3 times x plus y squared, and then minus 4. Should we expand this? No, don't do that. Just leave it like that. Everybody will be happy. Seriously. Right? Yeah. Okay, so far so good, huh? And now let's take a look at some more crazier examples. Crazy enough that I have to erase the board. I just realized this right here is very tiring because I have to erase the board almost every single time. Even though the questions are not that hard, but it's like tiring. Okay, I will not complain anymore. Let's check this out. 85. Alright, x plus y times 2x. x plus y times 2x minus x squared times 1 plus dy dx. Everybody over x plus y squared equals 2y dy dx. Yeah. Okay, so how do we deal with this? We see that we have the dy dx here and then dy dx here, right? But we have this denominator. So let's multiply this on both sides. So that will cancel. And then right here, perhaps let's just distribute this guy. It's no power, so it's okay. So here we get 2x squared, yeah? And then plus 2xy, okay? And then I will also distribute this. Yeah, because I have to make sure they have separate terms, right? So distribute. So this right here will be negative x squared and then minus x squared dy dx. Yeah, make sure we are ready, just like earlier when we have stuff inside in front of the parentheses. If the dy dx inside, we have to distribute it. Yeah, so far so good. And then we'll put this right here. So this is 2y x plus y squared and then dy dx. And for this one in particular, I'm going to move this to the right hand side so that I can keep all this positive. Okay, so right here I'm just going to leave it as 2x squared plus 2xy minus x squared, and then that's equal to this is still here on the right hand side, so 2y times x plus y squared. Bring this to the other side, becomes a plus, and then we have x squared like so, and then dy dx. Shall we expand this? I'm going to leave that to you. Did I expand it? No, I did not expand that. No, I did not expand that. And oh, notice I forgot this thing that we can do. Check this out. 2x squared minus x squared, we can just say x squared and then put 2xy. Yeah. Now let's just divide. So ladies and gentlemen, dy dx equals this thing, which is x squared plus 2xy over, perhaps I'll write this down first because that will line up with the x squared, yeah? So this first, and then that's a plus 2y parentheses x plus y squared. Done. Number 86. Right, x to the third power times 2ln and then times 1 over y times dy dx, and of course ln y, the y is inside of the ln, so do not cancel this y and that y. Okay, don't do that. You have to have an input. If you just have ln, that doesn't make sense. It's just a name. It's not a function or whatnot. So we have all this. Plus parentheses ln y square 3x square, and then add dy dx, and this is equal to 0. Yes. All right. How can we do this? Well, if you take a look at this equation, we do have a little denominator, so let's just multiply everybody by that denominator. So I'm going to multiply everybody by y. Yeah, before we proceed, we just multiply everybody by y. So when we do this times that, they cancel. And in the meantime, we can also factor out the dy dx, right? So I'm going to just put this down. We have this. So we have 2 x to the third power, and then ln y. This and that will be cancelled already, okay? But this times that will be y, and that will be plus here. And then we have the dy dx. How's that? Yeah. And then I will move this to the other side. So that will be negative. And then we have 3x squared. And then here we have the y. So perhaps I'll indicate this y in red as well, because we multiply this and that. So that's how we have the red y. And this times that, that's how we get the red y here. And then we have that parentheses ln y squared. Yeah, so that's how you do it. Because now, if you don't have denominators, we can just simply divide this on both sides. So we have dy dx equals negative 3x squared y ln y squared over that, which is 2x third power ln y plus y. Done. E. Yeah, I make a mistake on my answer key. I will have to fix that. I cannot believe I'm actually doing okay with that. And now the next one's a killer. Oh my goodness. If you guys take a look at the next one, number 87, just the answer is like humongous. Oh my goodness. All right, so I'm going to erase the board again. All right, number 87, 2x plus 2y dy dx. All right, 2x plus 2y dy dx equals 1 over square root of x squared plus y squared, and then parentheses 2x plus 2y dy dx, and then minus 2 dy dx. Now, how do we even do this, right? Don't worry, just follow the fundamental. If you look at the equation, if it has fraction, it's usually a good idea to multiply everybody by the lowest common denominator, and this is the only denominator that we have. So let's multiply everybody by that, which is square root of x squared plus y squared. Yeah, so do not distribute, just get rid of that first. Yeah, so let's see. If we do that, we get 2x square root of x squared plus y squared, and then plus 2y square root of x squared plus y squared, and then dy dx equals, that will be cancelled, so just this, which is 2x plus 2y dy dx, and then minus 2 square root of x squared plus y squared, and then dy dx. Now we have this and that, they have the dy dx. So I'm going to move this to the right hand side. Yeah, so let's see, this stays, yeah, so it's 2y, and then this stays, which is minus 2 square root of x squared plus y squared. Bring this to the other side, that becomes a minus 2y and then square root of x squared plus y squared, and then we have that dy dx. And this stay here, and we'll put the 2x to the other side. So we have 2x square root of x squared plus y squared minus the 2x. Oh, I think my answer key is wrong. I'm going to fix it. I think this one is correct. Okay, let me just double check. This is not T. Yeah, this is right. Of course. Why not? Yeah. Okay, so divide this on both sides and we're done. Okay, ladies and gentlemen, dy dx equals that on the top. So we have 2x square root of x squared plus y squared and then minus 2x. You want to factor out the 2x? Be my guest. Oh my goodness, we can actually factor out 2. That's okay. I'm going to factor out 2 and then cancel out the 2. There are a lot of 2's. Fine, I will factor out the 2. Okay. So, you know what? Before we do that, let's just we can handle this. Let's divide this by 2, divide this by 2, divide the whole thing, okay? Divide the whole thing right here by 2. And I'm not dividing this by 2 because it's like multiply this by 1/2 and then distribute the 1/2, yeah? So, don't look at the 2's anymore. Yeah. Anyway though, dy dx equals, I'll just have the x, square root of x squared plus y squared minus x over y minus the square root of x squared plus y squared and then minus y square root of x squared plus y squared. Yeah, just like that. E. I think this is okay. Let's see. I don't know what I was doing when I was coming up with the answer key. Alright, so yeah, I think this is okay. Yeah, I'm gonna box this. So yeah, this should be the answer. If not, then let me know like if I missed anything. But anyway, that's all. Okay, just a couple more questions to go, but not really though, because the partial fractions are the ones that's horrible. Okay, let's see. Number 88. 1/2 square root of x plus y times 1 plus dy dx. This is equal to 4 x to the third power plus 4y to the third power, and then we have dy dx. Alright, so here's the thing. We have this again, and then it's an equation with a fraction, right? So let's multiply everybody by that denominator, which is 2 square root of just x plus y. Alright, so this times that will cancel, so we just have 1 plus dy dx. So put this times that, so 4 times 2 is 8. X to the third power square root of x plus y. This times that is plus 8 y to the third power and then square root of x plus y, and then dy dx. So this is the third power for the x, not the cube root. So just write it down nicely for you guys. So that's pretty much all we can do for simplify. So I'm going to, let's see how I put on the answer key for this one. I'm going to move this to the other side. So this is a 1 dy dx, right? So I will have this 1 right here, and then this to the other side becomes a minus 8, and then y to the third power, and then square root of x plus y, and then dy dx. That's equal to this stays, which is 8x to the third power square root of x plus y. This one to the other side, so we have a minus 1. And then in the end, we can just divide down both sides. Yeah, that is it. That's it. That's it. Okay, so let me just write down the answer. dy dx equals 8x to the third power times x plus y in the square root minus 1 over 1 minus 8y to the third power times the square root of x plus y. Done. Alright, number 89, we have 1 over x minus 1 over 9. No, 1 over x minus 1 over y, and then dy dx. And that's equal to e to the xy times the parentheses x dy dx, and then plus y. Alright, so that's what we have. Now, this is an equation, and we have x and y for the denominator. So let's go ahead and multiply everybody by both x and y, like this. So, take this times that, x will cancel. So firstly, we will have y. Next, we will have x, and then we have dy dx. Good. And then next, we are going to have the xy here, and then multiply by that, right? So just keep in mind we have x, y, e to the xy, yeah? And then we'll take this, distribute. So x times x is x squared. And then y, and then e to the xy, and then dy dx. And so take this, multiply by that, we get this. And then next, we take this times that, so plus x and the y squared e to the xy. Yeah. Okay, to keep things positive, I'm going to move this to the other side and then move this to the other side. So we have this y here. This doesn't have the x, this does not have the dy dx. Put it to the other side, so it becomes a minus x y squared e to the xy. That's equal to, okay, so I'll leave this, which is x squared y e to the xy plus x and then dy dx. So that's pretty much how I do this kind of questions. And then lastly, just divide this on both sides. So we have dy dx equals, over there we have y minus x y squared e to the xy over this right here. And because the order of addition doesn't matter, and I like to have the single term that goes first, right? Just x. So let's put the x first. Plus x squared y and then e to the xy. Yeah, that's how I have on my answer key as well. Oh, just like that. All right, one more with the differentiation. One more with the dy dx business. Number 90. Okay, e to the x over y times y minus x dy dx over y squared. And this is equal to 1 minus dy dx. Okay, first thing first. This equation has the y squared on the bottom, right? So let's multiply everybody by y squared. So when we take this times that, they cancel. But in the meantime, let's also distribute this inside. Yeah? So first we get y e to the x over y's power, and then minus x e to the x over y's power, and then the dy dx. And then take this times that, we get y squared. Take this times that, we minus y squared dy dx. Now, I'm going to move this to the other side. So, this was negative. Move it to, hold on, how did I move it? Yeah, let's move this to the other side. So, we will have y squared being positive here. And then this right here stays inside, right? Minus x e to the x over y, and then dy dx. And that's equal to this right here, still y squared. But bring this to here, so we have minus y e to the x over y. Alright? And lastly, let's just divide that, and we'll be done. So dy dx equals y squared minus y e to the x over y over y squared minus x e to the x over y. Okay. 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 It's only 4 hours and 17 minutes. But like 5 a.m. Why am I doing this to myself, huh? Okay. Partial fractions. Some of you guys might have done it in pre-calc, some of you guys have not. Doesn't matter though. But let me tell you, if you're only taking calc 1, this right here, you don't have to worry about it too much. But if you're taking calc 2, then make sure you come back here and see how we solve for the A, B, C, D for partial fractions. This is good. All right. All right. So for partial fractions, the idea is that how we can break down, how we can break a big fraction into smaller pieces. Take a look at number 91. If we look at 2x plus 1 over x plus 1 times x plus 2. I'm just going to tell you that we can break this apart as some number a over the first denominator x plus 1 plus some other number, we call it capital B, over the other denominator, which is x plus 2. And if you think about it, it should make sense, because when we have these two little fractions, when we add them, of course, we'll get this for the denominator, and we just have to find out the correct number a and b so that we can end up with 2x plus 1, right? Just like what we did earlier for the LCM, and also how we did for the lowest common denominator and then combine the fractions. But right now we're just doing this backwards. I'm not going to go over like how we break it down in details. I have another video for that. But this, we're just going to be solving equations. Here we go. Number 91. This right here, it's an easy case. I'll tell you. A and B can be very easily done, right? I'm going to tell you guys how. Well, of course, obviously. Let's do it. If you want to, I'm going to show you guys a short way, but I'm going to give you guys a proof of the short way first, and then I'll give you guys a short way. Let's do it. Just 10 more questions. I want to solve for a. A has x plus 1 for the denominator. You know what? We have an equation. Let's just go ahead and multiply this by that denominator, namely x plus 1. Just that. Just that. You'll see why. When we take this multiplied by that, you get 2x. So by the way, this is for a. Okay, for a. We get 2x plus 1 over this, and that will cancel. So we just have x plus 2. And then this is equal to a. They cancel already. And then plus b over x plus 2 times x plus 1. And you see, a is pretty much alone, right? Doesn't have the denominator anymore. But b does. However, not only b has the denominator, but b also has the x plus 1. If we can somehow get rid of this term, then we can get the a. But how though? Well, how can we make this term equal to 0? X has to be what? Negative 1. See? If we put negative 1 here, this will be 0, so this term will be 0. Yeah. So, what we are going to do is, we are going to let x equals negative 1. And just plug into all the x's. So we are going to get 2 times negative 1 plus 1 over negative 1 plus 2. And this is going to give us the a value. I will show you. This is plus b over negative 1 plus 2 times negative 1 plus 1. This is just equal to 0. Yeah, no more. So as you can see, a is just equal to that. So a is equal to what? Negative 2 plus 1 is negative 1 over 1. So just negative 1. A is just equal to negative 1. Done. Yeah. And in fact, you are going to notice we don't have to go through this every single time, because we can actually just look at this and then just do the so-called cover up. Just cover up the same denominator and then plug in x equal to negative 1 for here and here. You see, this is what we have. This is what I mean. I'll do this one in blue. This is the so-called cover up method. Okay? Look at this equation. I want to solve for a. A has x plus 1 for the denominator. We go back to the original. We cover out the same denominator, but we have to ask ourselves, how can we make x plus 1 equal to 0? X has to be negative 1. So x has to be negative 1. And we put this in here and here. So we just write it down. 2 times negative 1 plus 1 over negative 1 plus 2. That's going to be negative 1, and then we are done. This is the reason why it works. This is the reason why it works. And let's practice the cover up for b. For b, well, it has x plus 2 for the denominator, so we go back to the original, cover the same denominator, but x plus 2 equal to 0, x has to be what? Negative 2. So I'm going to put in negative 2 here. And then I will plug in negative 2 into here and here. Yeah, of the remaining x's. So we are going to get 2 times negative 2 plus 1 over negative 2 plus 1. Now check this out. This is negative 4 plus 1 is negative 3 over negative 1. Altogether, we get positive 3. So we are done. And that's exactly what we're trying to do. We're trying to figure out what a and b's are. So right here, I'll just tell you a equals negative 1, b equals 3. So we can come back here and say this is negative 1 and b is equal to 3. And if you combine these fractions, like the way I showed you earlier, you'll get that, guaranteed, right? So this is why the carve-out works. And let me tell you, the carve-out works nicely when we have linear denominator, meaning x to the first power. Yeah. And then another thing is that you have to make sure that the denominator is the same as the original fraction. All right? Yeah. So I think this is clear. If you want to go through B, just multiply out everybody by x plus 2 and then work it out like that. Okay? But I'm not just going to show you guys the carve-out because there are also other cases. Because what if you have the x squared plus 4? Then in that case, carve-out does not really work. I'll show you guys though, just don't worry. Next one, 92. Notice this one, we still have the same numerator, 2x plus 1. But the denominator, I changed it a little bit. Earlier it was x plus 1 times x plus 2, right? But this time, instead of just the first power, we have the second power. And you will see the breakdown is the following. I will tell you. We still have this for the first fraction, right? X plus 1. On the top, we don't know what the number is, such as a. And then the second fraction, we have this for the denominator, which is x squared plus 2. But notice, we cannot factor x squared plus 2 with real numbers. So, if this is the irreducible quadratic, the top will be set up as a linear, meaning we have bx to the first power plus c. So this is quite different than what we had earlier. And for more explanation, you can check out my other video for it. Now, we can do a carve-out for one of the letters, and that is a, because this and that have the same denominator, and we can cover this up and make it equal to 0. So for a, this is just going to be when x is equal to -1, like what we did earlier. We cover this up, so just put the -1 into here and here. So we get 2 times -1 plus 1 over -1 squared plus 2. That's -2 plus 1 is -1 over, this is 1 plus 2 is 3. So a is equal to -1/3. So we are good for that. But now the problem is that, you see, we have bx plus c on the top of the x squared plus 2. If we cover this up, like, what are we solving? B or c? That's a problem, right? So the carve-out does not really work for B or C. So what we do here is the traditional way. I think the traditional way is the way that students can follow along much better, especially the first time when we're doing this. Traditional way, multiply everybody by the whole denominator. This and that, just this and that, the whole common denominator. Right? So that we will see the left hand side is 2x plus 1, and then the right hand side, take this times that, the x plus 1 cancels, so we have the -1/3. We know the a already, so definitely use the cover up whenever we can. So -1/3, they cancelled it, but we still have to multiply by x squared plus 2. Next, we take this times that, x squared plus 2 cancel, but we still have the plus bx plus c times this, which is x plus 1. Okay? And then right here, we're just going to work out the right hand side. So same thing, distribute, and then told you this is the algebra drill. Just algebra. Whew. Alright, so this is -1/3 x squared and then minus 2/3. And for this right here, just multiply this out. This is plus bx squared and then plus bx and then plus cx. And then lastly, we have the plus c. And then next step is we collect the coefficients. Notice this and that, they both have the x squared term, right? So we can put down negative 1/3 plus b and then x squared. Next we have bx and cx. So we can say plus b plus c and x. And lastly, they are the terms with no x, so we can just say plus c minus 2/3. Now, we're going to play a game called mix and match. Take a look at the left hand side. Originally, we just have 2x plus 1. We do not have x squared, yeah? So technically, that's 0x squared. But you see, on the left hand side, we have 0 for the coefficient of x squared, but on the right hand side, we have this for the coefficient of x squared. So what does that mean? That means this must be equal to 0. So right here, we must have negative 1/3 plus b. It has to be equal to 0. Match the coefficient. Once we set this condition, we can solve for b. b is simply just 1/3. Right? So a is this, b is that. How about c? Well, depends how you like it. You can set up this to be 2. Right? We know b already, you can put it here. And then you can say c, no, 1/3 plus c has to be 2. Or we can also use the last term. Constant term here. Constant term here. So this means c minus 2/3 has to be equal to the constant term on the left hand side, which is 1. And if we have this, just add the 2/3 on both sides. So c equals 1 plus 2/3 is 5/3. Yeah. So that's it. Yeah, that's it. I love the algebra, I told you. The more comfortable you are with algebra, the better time you will have in calculus. I know some of this are super long, but you know, I'm doing this with you guys. Maybe you don't need to listen to all my explanation because they are just algebra, right? But hopefully, this video can inspire you to actually just practice your algebra skill and then pay more attention to your algebra. And yeah, just like a little encouragement for you guys. That's my goal. Hopefully that this right here is not teaching you guys anything new. It's just like telling you guys that you should practice this, that, and then just a lot of work. I know. Okay, next one. Number 93. We have 2x plus 1. Again, same numerator. Because I have that video talking about how to break down the fraction, that's why I'm using the same exact numbers, and then it's just how you pay attention to the denominator. But anyway, first, we still have x plus 1, but here we have x squared. Notice this is x squared, unlike x squared plus 2. Earlier, this factor was not factorable, but this right here is, because technically x squared is the same as x times x, meaning just x multiply itself twice. It's kind of factorable. It's called a repeated factor. Okay, but I will tell you, we can break this apart as some number a over x plus 1, and then plus some number b over just x, and then some other number c over x squared. You might be wondering, how did we end up with this right here, right? Well, you can check out my other video to see how we break down the partial fractions. Hold on, let me just take a look at the... Good. Alright. Good news for you guys. We can solve for... We can use cover up for 2 letters. They are a and c, because this denominator happens from the original, and we have the same thing right here. Yeah, so whenever we can use the cover up, go ahead and use it. A will be, you guessed it, x will be equal to -1. Put it here. So we have 2 times negative 1 plus 1 over negative 1 square. That's negative 2 plus 1 is negative 1 over 1, just negative 1. Yeah. And then let's also do the c here. C equals, this has x squared. I come here, I copy this. How can we make x squared equal to 0? X has to be 0. Yeah. And then we put 0 here and here. So we have 2 times 0 plus 1 over 0 plus 1. And that's just equal to 1. Alright? So we see a is equal to negative 1 and c is equal to 1. And you might be wondering, how come we cannot do cover up for b? Well, this is only x to the first power. If we use 0 here, we used it already. No, we cannot do cover up for b. So let's do it the traditional way. Let's multiply everybody by the denominator, x squared, x plus 1. So on the left hand side, we get 2x plus 1. On the right hand side, we have the negative 1. This and that cancel, and then we multiply by x squared. And then next, x and x just cancel one of them, right? And then the b we still don't know, so plus bx. And then one more this term, which is x plus 1. Then this and that cancel. C is 1, so we just have that. And then work out the right hand side. So this is negative x squared plus bx squared plus bx, and then plus x plus 1. Here, you see that we can combine this and that, which is just negative 1 plus bx squared. And we don't need to care about the rest. Because when we have this right here, again, the left hand side is 0x squared. So we must have negative 1 plus b equal to 0, meaning b has to be equal to 1. Once we have this, we are done. We don't have to continue with the rest. So a is negative 1. B and C happen to be 1 in this case. Yeah, it just happened to be the same number. But we cannot do cover up for B. Okay, we couldn't do cover up for B, even though it seems like, yeah, just a coincidence for that. You'll see the next one. It's very similar, and then we cannot do cover up. It's tiring. 5:30. Right, number 94. We have, again, 2x plus 1 over, here we have x plus 1 again, and then instead of x plus 2, because this is actually question 91, right now we have the second power. So this right here means x plus 2 happened twice. If it's happening twice, then we will have to build up the power when we set out the partial fraction. So it looks like some number a over the first denominator, which is x plus 1, and then build up the power starting from this to the first power, so x plus 2, and then go up one more time, x plus 2 square, and then c. Yeah. Okay, so you see this is similar to what we had earlier, right? We built out the power. Earlier was x and x squared. We can use cover up for a and c. Let's go ahead and do it. A will be when x equals negative 1. Put it here, so we have 2 times negative 1 plus 1 over, put negative 1 here, plus 2, and then square. That's negative 2 plus 1 is negative 1. On the bottom is 1, so it's negative 1. A is negative 1. Okay. And then C equals when x equals negative 2. right? Come here, cover out the whole denominator, c is equal to -2. Cover this up, but you put the -2 here and here. So we have 2 times -2 plus 1 over -2 plus 1. That's -4 plus 1 is -3 over -1. So c is equal to 3. So we got our a and c already. Now, to find b, we cannot use cover up, and it's not the same number as 3, okay? No. So let's just go ahead and do the traditional way. Multiply everybody by x plus 1 times x plus 2 square. Okay, let's see what this is going to give us. Left hand side, we still have 2x plus 1. This times that, the x plus 1 cancel. A is -1. So -1 times this, which is x plus 2 square. B we don't know, so keep it. X plus 2, cancel one of them, but we have this term, which is x plus 1 and then x plus 2. And then x plus 2 square cancel, so we have c, but c is 3. So we'll just say plus 3 times x plus 1. And then work out the right hand side. So let's do this in our head. Open this, we get x squared, but negative, plus 2 times this and that, which is 4x, but negative. Lastly, plus 4 squared, but you change that to negative. Okay. All right, next. X times x is x squared, but we have the b, so bx squared. Next, this times this is 2x, and this times this is x, so together was 3x. 3 times b, so plus 3b x. And then lastly, 1 times 2 is 2, but times b, so plus 2b. And in fact, you don't need the last one, but might as well. 3x plus 3. And the reason is because just like earlier, in fact, we just care about this. Yeah. Okay, so we get -1 plus b times x squared. And again, 0x squared, 0. So b, -1 plus b equal to 0. B is equal to +1. Yeah. This middle term is not always +1, okay? But I just want to tell you. But I do want to show you that b and c, they are not always equal either. So this is how you have to just set it and work it out. That was number 94. And then let me tell you, we are going to move on to like some other numbers rather than these. Alright, number 95. Here we have 3x minus 5 over x minus 1, x minus 3, and minus with one more, x minus 5. And you see, we have 3 distinct, meaning different, right? 3 distinct linear factor. When we break it apart, we get 3 little fractions. So each one we have, x minus 1, and the next one will be, each one will have their own denominator, non-repeated. Yeah, so just like this. And the good news is that we can use cover up all 3. So let's go ahead and make that happen. A equals, it has x minus 1, cover this. So this time a is equal to 1. Well, let x equal to 1. Put it here, and put it here. So we get 3 times 1 minus 5 over 1 minus 3 times 1 minus 5. Okay, that's 3 minus 5 is -2 over, that's also -2, so they cancel. And then that's -4 on the bottom, so -1 over 4. Yeah, I got it right. I'm looking at my answer key. Okay, next, b is Well, cover up this denominator, x has to be 3. So x is equal to 3. Put it here, put it here, put it here. So we have 3 times 3 minus 5 over 3 minus 1 times 3 minus 5. Okay, that's 9 minus 5 is 4 over 2 times negative 2. So altogether is negative 1. Yes. Yes. Okay, and lastly, c is equal to, cover this, x has to be 5. So 3 times 5 minus 5 over 5 in here, right? So it's 5 minus 1 times 5 minus 3. So that's 15 minus 5 is 10 over 4 times 2. Why is this so hard? This is 8. Reduce is 5 over 4. Yay. So, done. Just like that. Yes. Okay. Couple more questions. Seriously. '96. We have 1 over 4 minus x squared. Alright? And then this is equal to a over 2 minus x plus b over 2 plus x. For this one, notice that the original denominator was not factored, but we can factor it ourselves, right? So in fact, factoring this, we get 2 minus x times 2 plus x. And then we do have this and that. And you know it, we can do cover up for both of them. Awesome. A equals, cover the same denominator. X has to be 2, right? 2 minus 2 is 0, so x has to be 2. And we put the 2 here. So we have 1 over 2 plus 2. So a is equal to 1 over 4. Done. And then b equals, cover this up, so x has to be negative 2. So x has to be negative 2. We put it here. We have 1 over 2 minus x is negative 2. And that's 1 over 4 again. Done. Yeah, that's a nice one. Okay. Okay. Number 97. First we have 12 over x to the third power minus 3x squared. Alright, let's see. Let's factor it. We can factor out x squared. And then we get x minus 3. Yeah? So that is what we have. And you see we have x squared here. So just think about what we did earlier. When we want to break it apart, we will have to build out the power because x squared means x times x. So the first thing we will have is some number over x. Next, we will have, go to x squared. Yeah, and then next we have that. So in this particular order, okay? All right, we can do cover up for 2 letters. What are they? B and C. So let's go ahead and make that happen. B equals, well, cover this, x has to be 0. Right, cover this, x has to be 0. So we are going to get 12 over 0 minus 3, which is negative 4. So b is negative 4. C equals, cover this, x has to be 3. So x is equal to 3, and we put it here. So we get 12 over 3 squared. This 12 over 6 is 2. Just kidding. Just kidding. 9. 12 over 9 is what? 4 over 3. Yeah. Alright, so far so good. And of course, this is not it yet because we still have stuff for A, right? So you know the deal, we cannot do cover up for A. So let's just go ahead, do the traditional way. Multiply everybody by the denominator, which is just x squared times x minus 3. And then let's see what this will give us. On the left hand side, we just have 12, and that's equal to A, we don't know. X, and one of them will cancel, so we have another x, and then x minus 3. Continue, x will cancel, B is negative 4. So we have negative 4 times x minus 3. Then C is 4 over 3. And this and that cancel, so we just have plus 4 over 3 x squared. So that's what we have. And now let's see. If we multiply this out, we get ax squared, right? Ax squared. And let me tell you, it doesn't matter, and then plus 4 over 3 x squared, because none of them will give us x squared. And then in fact, if you look at it, we must have a plus 4 over 3 x squared. So what does that mean? The left hand side, again, it was 0x squared, right? So that means this right here has to be 0, meaning that A has to be negative 4 over 3. Done. Not all the time it's like the opposite of A, not all the time it's the opposite of C though. Imagine if this right here, we have x squared plus 12, then it would be 1x squared. Then we will have to set this to be 1. Yeah, so just saying. But we're done. A, B, C, A, B, C, A, B, C. Right, number 98. Number 98, we have x squared plus 7x minus 3. So now you see like a numerator, I give you more stuff. And on the bottom we have 2x plus 1 times x minus 2 squared. Right, so again, this means x minus 2 times x minus 2. So we had to build out the power. And the first term is, the first denominator is 2x plus 1, so this is what we have. And then build out the power, so we have plus x minus 2 to the first power, and the top is just a constant. And then another constant over x minus 2 squared. Okay, cover up 2 people, right? A and C, so let's make that happen. A equals, cover this up, 2x plus 1 equals 0. X has to be negative 1/2. Yeah, this is a fraction 1. Oh my goodness. But we can handle it, right? Hopefully. I don't know. Why did I have to do this to myself? Anyway, negative 1/2 square plus 7 times negative 1/2, and then minus 3, and then put the negative 1/2 here, and then minus 2. Why did I do this to myself? Anyway, over there is 1 over 4, and then this is minus 7 over 2, and then minus 3. So multiply by 2, multiply by 2, multiply by 4, multiply by 4. 1 minus 14 is 13, negative 13. And then minus 12 is minus 25 over 4. Okay, so that's the numerator. And on the bottom, this is negative 2 over 2. So we have 5 over 2 negative, and square that, which we get 25 over 4. You're kidding me. So A is equal to negative 1. Yeah, that's correct according to my answer key. But yeah, so just compute it, fractions. Get the common denominator, and then the bottom just get the common denominator and all that stuff. Or use a calculator. If you can use a calculator, just go for it. Anyway, B equals, no, cannot do it for B. C equals, cover this up, x has to be 2. Yeah, so x has to be 2. Put it here, put it here, put it here. So we get 2 squared plus 7 times 2, and then minus 3 over 2 times 2 plus 1. Okay. 4 plus 14 is 18. Minus 3 is 15 over 5. 3. Yay. Well, nice numbers. Usually when we do partial fractions, when I set out the equations, I try to make it like nice numbers, because otherwise, yeah, people will go crazy, including myself. But anyway, a is -1 and c is equal to 3. For b, let's multiply everybody by 2x plus 1, x minus 2 square. On the left hand side, oh, I forgot to draw my blue arrow. X squared plus 7x minus 3. Okay, this and that cancels, so we have -1 times x minus 2 squared. And then b we don't know, so put on plus b. X minus 2 cancel one of them, and we have this and that, right? So 2x plus 1, x minus 2. And lastly, this and that cancel, so we have plus 3, and then 2x plus 1. Okay, you know the deal. Right here, let's just care about the x squared term. We get -1x squared, so, and then don't worry about it. This and that give us 2. Let's do this. 2 x squared, yeah? 2x squared, that's the only x squared term, but multiplied by b, yeah? And then we don't have any other x squared term. So you see, we must have -1 plus 2b x squared. But this time though, on the left hand side, this is a 1x squared. So that means this right here has to be 1. So -1 plus 2b equals 1. Move this, 2b equals 2, b equals 1. Okay, b equals 1. Done. Yeah, this is more like workout, both for the mind and also for the hand, because I've erased all this stuff. Let me see if I can finish by 6. Two more questions. Wow, number 99. Okay, 5 hours. Number 99. We have 8x squared minus 10x minus 3 over, we have x minus 4 times x squared plus 1. Notice this right here is an irreducible quadratic with real numbers, right? We cannot factor x squared plus 1 with real numbers. It's factorable if you do plus I minus I, but let's not do that. Anyway, this is linear, so we will have x minus 4 and then some number a on the top. And then for this right here, we will just have this right here, x squared plus 1, but the top is a quadratic, it's a linear. This is an irreducible quadratic, so the top will be linear. So we have bx plus c. Now, we can only do cover up for one letter, which is a. So let's just take advantage of that. X has to be 4. Yeah. So we are looking at 8 times 4 square minus 10 times 4 and then minus 3 over, put 4 in here, so we have 4 square plus 1. Wow, this is 16 times 8. $128. Yeah, and then minus 40, so it's 88, and then minus 3 is 85. This is 17, so we get 5. All right, so this right here is equal to 5. All right, B and C, traditional way. Just go ahead and do it. X minus 4, x squared plus 1. So take this times that, we will have, well, blue arrow. So we have 8x squared minus 10x minus 3. This is equal to 5. This is not cancel, but we have that x squared plus 1. And then next, we will have this and that cancel, so this times that. So plus bx plus c with x minus 4. Yeah. And then just multiply. So this right here is 5x squared plus 5. This times this is plus bx squared. This times this is minus 4bx and then plus cx. And then lastly, minus 4c. Now let's look at 5 plus b, right? That's the x squared term. And then let's do this. This and that is plus negative 4b plus cx. And lastly, we have the 5 minus 4c. So plus 5 minus 4c. All right. This right here, 5 plus b x squared, it must be equal to 8, right? So b has to be 5 plus 3 is 8, so b has to be 3. Yay. So a is 5, b is 3. And then let's use this right here. This has to be the same as negative 3. So negative 4c has to be equal to, move this to the other side, so negative 8, so c has to be 2. Yay. So this time we see that b is 5, c is 3, and then, so b is 5, b is 3, and then c is 2. Yeah, they are all different numbers. It's not like opposite of each other or whatnot. But anyway, 99. Take a look. Okay. Oh my god. Ladies and gentlemen, question number 100. Wow. Question number 100. Here we have x plus 2 over x to the 4th power minus 1. And then if we factor this, we get x squared minus 1 times x squared plus 1, right? But x squared minus 1 can be factored here again. So if you look at this, it's actually x minus 1 times x plus 1 times x squared plus 1. So we have 3 factors. And the last one is an irreducible quadratic. So the setup is some number a over this denominator, and then some number b over that denominator, and then a linear term over this denominator. So cx plus d over x squared plus 1. Yeah. All right, good news. Cover up for A, cover up for B. Get to work for that, right? So A equals, same denominator, cover this up. X has to be 1. Put it here, put it here, put it here. So we have 1 plus 2 over 1 plus 1, 1 square plus 1. Okay, so that's 3. 2 times 2 is 4, so it's 3 over 4. That's A. And then B equals, X has to be -1. So X equals -1. Put it here, put it here, put it here. So we have -1 plus 2 over -1 here, minus 1 times -1 square plus 1. Okay, so on the top is 1 over, this is -2 times 2. So it's 4, but negative. So B is equal to -1 over 4. Yay, I got it right. Okay, and now the moment that we have been waiting for, right? C and D, yes, we have to just do the traditional way, huh? So this is 3 over 4, and B is equal to -1 over 4. All right, so x minus 1, x plus 1, x squared plus 1. Alright, so here we have x plus 2, and this is equal to, here we have 3 over 4. This and that cancel, so we have this and that, so it's x plus 1 times x squared plus 1. Next, we have b, which is -1 over 4. This and that cancel, so we have x minus 1, x squared plus 1. And lastly, this and that cancel, we have plus cx plus d times this. Two together is x squared minus 1. So I'll just multiply by x squared minus 1. Yeah? Okay. Just do the algebra, right? Okay. So let's multiply this and then distribute the 3 over 4. So here we get x to the, oh, this is hard. Let's see. This times that is x to the third power, but multiply by 3 over 4. Next, I'll take this times that, which is just x, but then I will multiply by 3 over 4. Next, I'll do this times that, which is plus x squared, but I will multiply by 3 over 4. And lastly, 1 times 1, I will have that 3 over 4. Okay? All right. Let's do this. So this times this is x to the third power, distribute the negative, so we have minus 1 over 4 x to the third power. This times this is x, but multiply by negative 1 over 4. And then this times this is negative x squared, but multiply by this, which becomes positive 1 over 4. And lastly, this is negative, but multiply by that becomes positive 1 over 4. Okay, and then multiply this out. So cx to the third power. Then this times this is cx. And then dx squared. Lastly, d. Alright, let's see. Show me the x to the third power. Okay, well, this, and that. Okay, so we see that we have 3 over 4 minus 1 over 4 and then plus c, x to the third power. So thanks to this, we can figure out what c is, and then because we can use a unit, we can use a last number. We have d right? It has no x. And then this has no x. Plus 3 over 4 and plus 1 over 4. It has no x. Alright, so let's figure out what this is. This is x to the third power term. And here we have no x to the third power. So this right here should be equal to 0. So this and that, 3 over 4 minus 1 over 4. 2 over 4, which is 1/2, plus c equals 0, c equals negative 1/2. Yay. And then this right here is this term. Yeah? So it should be equal to 2. And that's 1. So d plus 1 equals 2. So d equals 1. c is negative 1/2 and d is equal to 1. Done. 100 questions. Just algebra. Yeah. All the algebra. Well, I cannot say all the algebra that you'll see in calculus because there are a lot more, seriously. Yeah, but it's a matter of you if you want to practice or not. And the better you are with algebra, the more comfortable you are with algebra, you will have a better time in calculus. Because, well, first I will tell you, sometimes when you learn calculus concept, it's hard already. But if you also struggle with the algebra, that will be impossible. Algebra should be your second nature when you do the computation, okay? And then if you have algebra done, then you can really enjoy learning calculus. And I know, what happened to the trick, right? I'm going to come with something else for you guys for trick. But right now, 100 question. I know, as a tradition, I should do 101, right? So, am I going to do 101? Yeah, let's do 101 now. What exactly am I going to do for 101? I really didn't prepare. Really didn't prepare. Let's complete a square. How's that? How would you complete the square CTS? Let's just do a small example. How would you complete a square for solving this equation? X squared. No, let's just complete a square. Because when you do, what's that called? Partial fractions, sometimes you might have to complete a square, right? How would you complete a square for this? X squared plus 8x. Yeah. Well, first I'll tell you, we have to make sure the coefficient of x squared is 1. Indeed, it's 1. Good. Then you do the following. Look at the coefficient of x, which we have 8. Then what we do is, we take half of that number, which is half of 8, and then we square it. I call this the magic number. Half of 8 is 4. 4 squared is 16. So if we have this right here, we are going to write it as x squared plus 8x. And then we can complete the square by adding the 16. But this is going to change the whole thing. This is not the same as the original anymore, right? Don't worry. Just go ahead and minus 16 after that. And then the magic number is so powerful, so magical, because the first three term is the power of the square. X plus 4 times x plus 4. So we get x plus 4 square, and then right here you see that we have that minus 16. So this right here is a perfect square. That's how you complete the square when you have a quadratic term. And we've just focused on this too. Yeah, and this is useful when you want to solve like quadratic equation, or sometimes if you want to do integral with this kind of weird things, then you complete a square, your life will be happier. There we have it, 101 algebra equation. Alright, so hopefully you guys can find this video helpful. If you're taking algebra, then you can get a head start. If you are taking calculus, then use this to practice and get comfortable with your algebra. This is my hand, and you know the deal. My mirrors on metal. Every time I put this on, it just feels so good. Alright, you know the deal. As always, that's it.